Hello there and welcome to Just About Earth, where we take our time to look at the big questions of life, the universe, and everything in between. We've always had a special way of looking at the world around us, one that's both curious and a little calming, like a quiet conversation among friends. But today, we're about to embark on a journey that might make you think a little deeper about the cosmos, our place in it, and what it truly means to be alive. You see, there's a quiet, eerie mystery that hangs over us like a veil, and it's one that we've all wondered about at some point in our lives. The universe, vast, infinite, seemingly endless, should surely contain life, right? There's no way that in all this space filled with billions of stars and planets, we are the only ones here, or is there? This mystery isn't about whether life exists, it's about the chilling possibility that it might not. That the silence of the cosmos, the stillness we encounter when we look up at the night sky, may not be just a random occurrence. It could be a sign that we're not only alone, but perhaps alarmingly so. It's a thought that's hard to escape once you let it sink in, and it's far worse than you might think. Have you ever taken a moment to really reflect on where you are right now? What time is it in your corner of the world? How does that moment feel in the grand stretch of time and space? A single moment, quiet and unassuming, but one that stretches through an endless universe. It's a question that, much like the thought of being alone in this vastness, can make us pause. Perhaps we're all just a brief flicker in the vast, indifferent expanse, each of us experiencing time, feeling the weight of existence, all while wondering what's beyond the edge of our reach. What's out there? Or, more hauntingly, is there anything at all? As we start this exploration, I want to invite you to think about that feeling of isolation, not just in the abstract, but in the context of the universe. If you find this journey of thought to be calming, intriguing, or perhaps unsettling in the best way, I'd be so grateful if you took a moment to like this video, maybe even subscribe. It helps this little corner of calm reach others who might also be looking for a place to ponder life's biggest questions. But don't worry, I'm not asking for your attention just yet. For now, just settle in and breathe. Let's talk about the universe for a moment. Picture it. A vast ocean of stars, a sprawling infinite sea that stretches far beyond what we can comprehend. Our understanding of this place is, in some ways, limited. We've made great strides, certainly. Telescopes, spacecraft and rovers that explore worlds both near and far, bringing back knowledge that we can barely process. But when we look at the cosmos, all that's left to us is silence. The stars burn brightly, distant and cold, but we don't hear a thing. Not a whisper, no signs of life, no voices, no civilizations calling out into the dark. Just silence. It's a silence that feels intentional, and one that many have struggled to understand. Why isn't anyone else out there calling to us, reaching across the void to say, "Hello, we're here"? Surely, with billions of stars and potentially habitable planets, we're not the only intelligent species in existence. Or are we? Let's take a step back and think about this from another angle. Imagine that we are the first. Imagine that intelligent life is so incredibly rare, so exceptionally difficult to arise, that we stand alone as a beacon in the dark, the first to reach the point where we can send messages into the vastness of space, where we can look up and wonder if anyone else is listening. What if the silence isn't random, but a sign that life itself, especially intelligent life, is something so fragile and rare that we might be the very first and the very last? This is the idea that we'll be exploring today, and it's a question that has unsettled many for years. If we're alone in the universe, it might not be because life is common, waiting to be found. No, it could be that intelligent life is staggeringly rare, so rare that the conditions needed for it to emerge are so extraordinarily specific that it is almost impossible for any other civilization to have the same fortune. What if we're not just looking for something we haven't found yet, but looking for something that might have never existed at all? This thought, though disquieting, is backed by something called the rare earth hypothesis. It suggests that the conditions required for life, particularly complex life, are so exact, so fragile, that Earth, with all its delicate balance of elements and circumstances, might be the rarest of anomalies. The right distance from the sun, the right chemical composition, the right magnetic field to protect us from solar radiation. All of these factors came together perfectly for us to evolve. But what if such a collection of factors is so rare that the chances of it happening again are astronomically low? We might very well be living in a unique moment in the history of the universe, one that is entirely unrepeatable. But the question doesn't stop there. What if the universe isn't just silent because life is rare, but because intelligent civilizations have a tendency to wipe themselves out before they can reach the stars? There's a theory that explores this idea called the Great Filter. It suggests that there might be a significant, unavoidable obstacle that every intelligent civilization faces, something that stands in the way of them advancing beyond their planet, something so devastating that most civilizations never make it past this point. Whether it's self-destruction, environmental collapse, or something we haven't even considered yet, the Great Filter suggests that the reason we're not hearing from anyone else is because most civilizations fail before they can reach the stars, and it doesn't end there. The Fermi paradox brings another layer to this mystery. If there are so many stars, so many planets, and so many opportunities for life, why is the universe so quiet? Why, after decades of searching, have we not found a single definitive signal, a single sign that we are not alone? The paradox is that the universe should be teeming with life, and yet there is nothing. Some propose that it's because intelligent civilizations inevitably destroy themselves before they can spread out into the stars. Others think that it's simply a matter of timing. We may be in the wrong place at the wrong time, and the civilizations that existed before us are long gone. Now, let's consider what this means. The fact that we might be alone in the universe, not because life is uncommon, but because it's either extraordinarily rare or constantly self-destructive, is a profoundly unsettling thought. It suggests that perhaps the universe is not just indifferent to us, but that it is the perfect breeding ground for loneliness. We may be the only ones to have made it this far, and yet, here we are, trying to make contact, trying to break through the silence with no guarantee that anyone is listening. Or worse, maybe no one ever will. So let's begin by exploring these ideas. Are we alone in the universe? And if we are, what does that mean for us, for humanity, for the future of our civilization? The answer is not as comforting as we might hope. In fact, it's far more chilling. But this is a question worth exploring. One that might just change the way we think about our place in the cosmos. And who knows? Maybe, just maybe, understanding our isolation could be the first step in truly understanding what it means to be human. As we look up at the night sky, it's easy to be swept away by the beauty of the stars, the sheer vastness of the universe, and the wonder of the unknown. We imagine the infinite possibilities that might lie out there. Planets filled with alien life, distant civilizations, and other beings reaching across the dark void to connect with us. The stars, like beacons in the darkness, seem to promise something more, something beyond our reach. But what if that promise is an illusion? What if the silence we hear when we peer into the night sky is not simply a result of the distance between us and others, but a sign that we might truly be alone? Alone in a universe that seems so vast, so full of potential, yet barren of any evidence of intelligent life. It's a thought that's as uncomfortable as it is unsettling. We've spent centuries looking for answers, sending out signals, listening for any sign of life, hoping for some cosmic echo of our own existence. But so far there has been nothing. The silence is deafening. The universe, with all its vastness, should, in theory, be teeming with life. The numbers alone are staggering. With over 100 billion stars in our galaxy, and an estimated 100 billion galaxies in the observable universe, it would seem almost impossible that Earth is the only planet with intelligent life. But the reality is far from what we might expect. The truth is, the universe could be empty, not because life is too rare to find, but because the conditions necessary for intelligent life to emerge are far more unlikely than we have ever imagined. This brings us to a chilling possibility. We might be alone not because life is rare, but because intelligent life is so extraordinarily rare, or because it tends to vanish before it can spread across the stars. It's a paradox of our own making. We search the cosmos for signs of life, but what if the absence of any signals is not due to distance or technological limits, but because the universe has a far crueler reality in store for us? What if life doesn't flourish beyond its birthplace, because the conditions required for it to thrive are so rare that they cannot be replicated elsewhere? This idea is called the rare earth hypothesis. It suggests that while microbial life might exist throughout the universe, complex life, the kind that can think, build, and explore, is far less common. The conditions required for such life are so specific, so finely tuned, that Earth might be one of the very few, if not the only, places where those conditions have come together. It's a sobering thought, one that challenges our fundamental assumptions about the universe and our place within it. And this idea is not just an abstract theory. It's a possibility that raises uncomfortable questions about our future. There's another theory, one that might be even more unsettling. It's called the Great Filter, and it suggests that civilizations, no matter how advanced, tend to destroy themselves before they can ever reach the stars. In other words, the reason we don't hear from anyone else is because intelligent civilizations tend to encounter a critical obstacle that prevents them from advancing beyond their home planet. Whether it's through war, environmental collapse, or some other catastrophic event, the Great Filter implies that most civilizations simply don't survive long enough to communicate or explore beyond their world. And what if we too are facing that same filter? The Fermi paradox ties into this idea. Named after the famous physicist Enrico Fermi, it's the simple question that has haunted astronomers for decades. If there are so many stars and planets in the universe, why haven't we found any evidence of extraterrestrial life? With billions of potentially habitable planets in our galaxy alone, the odds seem overwhelmingly in favour of life elsewhere. Yet, despite our best efforts, we haven't heard a single confirmed signal, detected a single alien presence, or made contact with anyone beyond our world. The paradox is this: if intelligent civilizations are as likely as we think, then why is the universe so quiet? The possibility that we are alone in the universe is far from comforting. In fact, it may be far worse than we imagine. It suggests that the universe isn't just a vast expanse filled with the unknown, but a silent, empty place where the conditions for life, let alone intelligent life, are so rare, so fragile, that we may be the only ones to have ever reached the point of asking these questions. The silence we hear may not be a lack of effort or communication. It may be a warning sign, a cosmic isolation that speaks to a deeper, darker truth about the nature of life and intelligence. It's a humbling, terrifying thought. And yet, here we are, on the edge of the unknown, looking up at the stars and wondering, is there anyone else out there? What does it mean to be alone in the universe? What happens to us, as a species, when we realise that our place in the cosmos might not be as special as we once thought? These are the questions we will explore as we confront the possibility that humanity might not be just one of many, but a lonely anomaly in a vast, indifferent universe. As we delve deeper into this mystery, we'll examine the theories and ideas that might explain why the universe is so quiet. We'll explore the rare earth hypothesis, the Great Filter, and the Fermi paradox in detail, uncovering what they might reveal about the nature of life, intelligence, and our future as a species. The journey ahead is not an easy one, but it is one worth taking, because in the end, understanding why we might be alone could hold the key to understanding who we are and what lies ahead for us as we continue our journey into the unknown. When we look up at the night sky, what are we really searching for? The stars, those bright points of light that twinkle in the darkness, are a constant reminder of just how vast the universe is. They stretch out in every direction, a dizzying expanse of unknown possibilities. But what exactly are we hoping to find when we turn our eyes to the heavens? Most of us have imagined that there's something or someone out there. It's a dream that has been with humanity for centuries. The idea that we are not alone in the universe is deeply embedded in our culture, in our myths and in our scientific pursuits. We send out radio signals and search for extraterrestrial intelligence. We look for planets that might harbour life. We've even speculated on what those alien civilizations might be like. But, in truth, what exactly are we hoping to find? At the most basic level, we're looking for confirmation that we're not alone. It's a question that transcends scientific curiosity. It's existential. The thought that there are others out there, others who might share our experiences, our questions and our desires, is incredibly comforting. We want to believe that the cosmos isn't just a cold, indifferent void. We want to feel connected, to understand that there's more to existence than our little corner of the world. If there are other beings out there, it means we are part of something much bigger, something that stretches across the stars. It gives meaning to our existence, our struggles, our triumphs. It reassures us that life is not a random occurrence, but part of a larger cosmic rhythm. But as we dig deeper into the question of what we're really looking for, it becomes clear that this isn't just about companionship or the excitement of discovery. No, we're also looking for answers to some of the deepest, most profound questions we've ever asked. We want to know, how did life begin? Why did it evolve the way it did on Earth? Could it happen elsewhere? What are the chances that other intelligent beings are out there, asking the same questions we are, wondering about the same mysteries? And if they exist, what are they like? Are they anything like us? Or are they so different that they exist beyond our comprehension? This search for alien life is, at its core, a search for understanding. We've spent millennia trying to understand our place in the universe. We've looked to the stars, to the planets, and to the vast reaches of space to answer questions about who we are, where we come from, and what our future holds. The discovery of even the simplest form of alien life would upend everything we know about biology, about the nature of life itself. It would force us to reconsider what it means to be human. And yet, as we send out our signals and cast our nets across the stars, we've found very little. The silence we encounter is deafening. But the question persists. Why? Why, with all the technology at our disposal, with the billions of stars and planets in the universe, have we not yet found any signs of intelligent life? We've been searching for decades. We've built massive radio telescopes, sent probes to the far reaches of the solar system, and used every tool at our disposal to try to detect signals, to catch a glimpse of something beyond our world. And yet, the silence remains unbroken. The absence of evidence is, in itself, a profound statement. If life is so abundant, so widespread in the universe, why is the search for extraterrestrial intelligence so silent? The lack of communication, the absence of signals, suggests that either intelligent life is far rarer than we thought, or that civilizations tend to self-destruct before they can reach out to others. It challenges our assumptions, forcing us to confront the possibility that we might be unique, or worse, that we are simply a fluke in the grand cosmic design. The question of what we're really looking for is not just a scientific inquiry, it's a deep, philosophical question. What does it mean to be human in a universe that may be devoid of other intelligent life? What does it mean to be alone in the cosmos? These are questions that challenge our identity, our place in the universe, and our future. And the answers we find, or don't find, could shape the course of human history for generations to come. But what if, in our search for the answers, we've been looking for the wrong thing all along? Perhaps, as unsettling as it may sound, the silence is not a mistake. Maybe the universe isn't teeming with life. And maybe we're not searching for something that's just waiting to be discovered. Perhaps instead we are looking for the wrong kind of life entirely. What if the conditions required for intelligent life are so rare, so improbable, that we might be the only ones who have ever made it this far? What if the silence is not an absence of life, but a warning sign? A signal that the path we're on, the very journey we're taking as a species, is one that most civilizations never survive. It's a thought that's difficult to accept, but it's one that we must consider. If we are alone, if intelligent life is so rare that it might only exist once in a universe, what does that mean for us? What does it say about our future? And if we are the only ones to have made it this far, can we continue to survive? Can we break free from the cycles of destruction that have doomed so many civilizations before us? Or will we too become a forgotten echo in the silence of the cosmos? As we explore these ideas, it becomes clear that what we're really looking for is not just alien life, but answers to our own existence. We are looking for meaning, for purpose, for a connection to something greater than ourselves. We are searching for a place in the universe that makes sense of our existence, a context that explains why we're here and how we fit into the larger cosmic puzzle. And so, as we continue our search for life, for intelligence, and for answers, we must ask ourselves, what are we really hoping to find? Are we prepared for the possibility that the universe might not be as full as we once thought? And what happens if we discover that we are truly alone? These questions may not have easy answers, but they are the questions that will guide us as we continue to search, to reach for the stars, and to try to make sense of the silence. The universe, in all its vastness, may not be as welcoming as we once imagined, but perhaps, in this search for life, we will find something even more profound. The realization that our existence, our ability to question, and our drive to understand are what truly set us apart in this grand, empty cosmos. When we step outside and look up at the sky, we are staring into what is, in every sense of the word, an ocean. But not an ocean of water, or even air. It's an ocean of stars, vast, infinite, and teeming with the unknown. The sheer size of the universe is staggering. The Milky Way alone, our own galaxy, contains roughly 100 billion stars, and yet we know only a fraction of what's out there. Every night we stare at the stars, and every night we ask ourselves the same question. Is anyone out there? The vastness of space, while awe-inspiring, can also be overwhelming. It's hard to fathom just how big the universe really is. The observable universe is about 93 billion light-years in diameter, and within that vast expanse there are billions of galaxies, each one containing billions of stars, many of which have planets orbiting them. The numbers are mind-boggling, and the odds of finding another civilization, or even a single sign of intelligent life, seem, on the surface, to be incredibly high. With so many stars and planets, surely it's only a matter of time before we discover that we are not alone. But that's where things get complicated. The more we search, the quieter it gets. It's important to recognise that we're not just asking if life exists in the universe, we're asking whether intelligent life exists. Life, in its most basic form, could be anywhere. Microbes, bacteria, single-celled organisms, they could be out there, thriving on planets orbiting distant stars. But when we think of life, we don't just think of tiny organisms. We think of beings with complex minds, capable of communication, technology, and understanding the universe around them. And when we search the stars, that's what we're really searching for. Intelligence. A mind that can think, create, and possibly reach out to us across the vast emptiness of space. But so far we've found nothing. The idea that intelligent life is out there is built on something called the Drake equation. This equation, proposed by astrophysicist Frank Drake in the 1960s, tries to estimate the number of technologically advanced civilizations in the galaxy. It takes into account factors like the rate of star formation, the fraction of stars with planets, the number of planets that might be capable of supporting life, and so on. It's a logical, mathematical approach to the question of whether intelligent life exists beyond Earth. According to the equation, the numbers suggest that intelligent civilizations should be common. But despite all the stars, planets, and potential for life, we haven't heard anything. That's where the Fermi paradox comes in. The paradox is simple. With so many stars and planets in the galaxy, the odds of intelligent life existing somewhere should be extremely high. Yet, we haven't detected any signals, seen any evidence of alien life, or made contact with anyone from beyond our planet. It's the contradiction at the heart of the search for extraterrestrial intelligence. If the universe is so vast and teeming with possibilities, why are we still alone? If there are civilizations out there, why haven't they made their presence known? And if they are out there, why are they so silent? The most disturbing implication of the Fermi paradox is that the silence might not be random. It might not just be a matter of bad luck or bad timing. What if the reason we don't hear anything is because intelligent civilizations are extremely rare, or worse, they don't survive long enough to reach out? The universe could be full of potential, full of planets capable of supporting life, but the gap between the emergence of life and the ability to communicate, to travel across space, or to survive long enough to make contact might be so vast that no civilization ever makes it far enough to reach us. It's the possibility that life is rare, not because it doesn't exist, but because intelligent life is incredibly hard to sustain. This brings us to the rare Earth hypothesis, which suggests that Earth might be the exception, not the rule. According to this hypothesis, the conditions required for life, especially complex, intelligent life, are so specific, so finely tuned, that Earth might be one of the few, if not the only, places in the universe where those conditions have come together. The fact that we exist, that we've evolved into a species capable of wondering about our place in the cosmos, could be a cosmic fluke. If Earth's conditions are so rare, then the odds of another planet being in the perfect position for life are extremely low. It's a sobering thought, and it casts doubt on the idea that intelligent life is out there, just waiting to be discovered. Then there's the possibility that intelligent life does exist, but it tends to disappear before it can reach the stars. This is where the Great Filter theory comes into play. The Great Filter posits that there is some critical barrier, some existential challenge that civilizations inevitably face. This filter could be anything: a deadly environmental collapse, the inability to manage technology without destroying oneself, or even the sudden collapse of a species for reasons we can't yet predict. The theory suggests that most civilizations never make it past this point, and as a result, we never hear from them. They fail before they can spread out across the galaxy. It's a chilling thought, because it suggests that we might be facing that very filter ourselves. If we are the only intelligent species in our galaxy, it might be because no civilization survives long enough to explore the stars. And if that's the case, the silence of the universe might not just be a cosmic accident, it could be a warning. But even if we take the rare Earth hypothesis and the Great Filter out of the equation, we're still left with the question of why the universe seems so silent. After all, the search for extraterrestrial intelligence, SETI, has been ongoing for decades. We've been sending out radio signals, looking for signals in return, and yet we've heard nothing. Our own radio signals, generated by everything from our satellites to our television broadcasts, are spreading out into space, but they haven't been met with any response. It's as though the universe is indifferent, or perhaps even hostile to the idea of contact. The silence is profound. If intelligent civilizations are out there, why aren't they reaching out to us? Why aren't we hearing their signals, seeing their ships, or finding evidence of their existence? Some propose that we're simply not looking in the right way, that we haven't developed the right tools or technologies to detect them. But this doesn't account for the sheer number of stars and planets we've already observed, nor does it explain the strange quiet that seems to permeate the cosmos. One possibility is that advanced civilizations may have learned the lesson of silence. Perhaps, like us, they have come to realize that the universe is not a friendly place. It's a cold, vast expanse, and the dangers of revealing oneself to other civilizations may outweigh the benefits. They may be hiding, keeping their presence unknown to avoid the risks of encountering a more advanced or more hostile species. The galaxy could be filled with civilizations, all playing the same game of cosmic hide-and-seek. Or maybe they've discovered that it's best to stay silent to avoid attracting attention. In some ways, the silence we face is a reflection of our own fear. The more we learn about the universe, the more we realize how little we truly understand. We've spent centuries trying to understand the cosmos, yet we are still in the early stages of our exploration. The vastness of space, the complexity of life, and the dangers inherent in technological advancement are all things that we are only beginning to grapple with. And as we reach out into the darkness, we are confronted with the unsettling possibility that the silence isn't accidental. It may be the rule, not the exception. So what are we really looking for when we ask, is anyone out there? We're not just looking for company or for reassurance that we're not alone in the universe. We're looking for answers to the most profound questions we can ask. We're searching for understanding, for a connection that transcends our existence. We want to know our place in the cosmos, to find meaning in the vastness of space. But as we search, we're also confronted with the unsettling reality that we may be looking for something that doesn't exist. The silence of the universe may not be an empty void. It may be a sign that the universe is in some way indifferent to our existence. The more we search, the more we begin to realize that the question isn't just about whether life exists elsewhere. It's about why the universe seems so quiet, and in that silence, we might find the most unsettling answer of all, that perhaps, in the grand scheme of things, we are truly alone. The question of whether we are alone in the universe is one that haunts us as we look up at the stars, imagining the possibility of life beyond our own world. For decades, scientists, astronomers, and dreamers alike have pondered the idea that somewhere out there, beyond the reaches of our small blue planet, intelligent life exists. With so many stars, so many planets, and so many chances for life to evolve, the odds should be in our favour. And yet, despite all our efforts, there has been no sign, no message, no signal, no evidence that any other civilizations are out there, reaching back to us. This is the heart of what is known as the Fermi paradox. Named after the physicist Enrico Fermi, the paradox arises from a simple question. If there are so many stars and so many planets that could harbour life, why haven't we heard anything? Where is everybody? It's a contradiction that has baffled scientists and astronomers for years. After all, we've been looking. We've been listening for signals from other worlds. We've been sending out our own broadcasts and searching the sky for signs of intelligent life. And yet, despite decades of searching, we've heard nothing. It's as if the universe is filled with silence. At first glance, the numbers seem to suggest that we should have encountered extraterrestrial life by now. There are an estimated 100 billion stars in our galaxy alone, and with many of these stars having planets orbiting them, the number of potentially habitable planets should be staggering. Some studies suggest that there could be billions of Earth-like planets in the Milky Way alone, each one capable of supporting life. If we assume that the development of life is not an impossibility, and that the conditions for life are not unique to Earth, it seems almost certain that intelligent life should have emerged elsewhere in the galaxy. So, why haven't we encountered it? Why haven't we heard any signals? Why haven't we seen any evidence of alien civilizations? These questions lie at the heart of the Fermi paradox, and it's a paradox that refuses to go away. For decades, we have searched for answers, but the more we search, the more questions arise. One of the most disconcerting aspects of the paradox is that it suggests the possibility that intelligent civilizations, despite their potential for widespread existence, are incredibly rare. The idea that we are the only intelligent species in our galaxy, let alone the universe, seems almost unfathomable, but the silence of the cosmos could point to that very possibility. The more we look, the quieter it gets. The paradox itself is simple, but the implications are far from it. The fact that we haven't detected any signals, seen any ships, or found any evidence of extraterrestrial life suggests that there might be something fundamentally wrong with our assumptions. What if intelligent civilizations are rare? Not because life itself is rare, but because the conditions that allow for the rise of intelligent life are so incredibly unlikely. The universe could be teeming with microbial life, but the jump from microbes to complex intelligent organisms capable of communication and technology might be so difficult, so improbable, that it only happens under incredibly specific circumstances. If that's the case, it would explain why we haven't encountered any other civilizations. We might be one of the very few, if not the only, intelligent species in the galaxy. Another possibility, and one that might be even more unsettling, is that intelligent civilizations tend to self-destruct before they can reach the stars. This is where the idea of the Great Filter comes into play. The Great Filter is a hypothesis that suggests there is a critical barrier that all civilizations must pass through in order to become technologically advanced and capable of interstellar communication. The theory is that most civilizations fail to make it past this barrier, either because they destroy themselves through war, environmental collapse, or some other form of self-destruction. If this is the case, the Fermi paradox takes on a darker tone. It would mean that the silence of the universe is not just an accident or a fluke. It's a sign that civilizations inevitably fall short. And if we are truly alone, it might be because we have made it past that filter, or perhaps, like many before us, we will fail to make it past. The idea of the Great Filter is particularly unsettling because it suggests that the universe may be full of potential, full of planets capable of supporting life, but that intelligent life rarely survives long enough to reach out to other civilizations. It's a chilling thought, that life may be common in the universe, but intelligence is not. We may be alone, not because intelligent life is rare, but because it is fleeting. If the Great Filter is real, it raises the question of whether we are already on the verge of reaching that point of self-destruction, or if we've already passed it. Are we the exception to the rule, or are we doomed to repeat the fate of countless civilizations before us? The more we explore the Fermi paradox, the more we begin to realize that it's not just about the absence of signals or the silence of space. It's about the nature of life itself. Why does life evolve in the way it does? Why do some species develop the capacity for intelligence and technology, while others do not? What conditions must align for a species to reach the point where they can send out signals, communicate with other civilizations, and explore the stars? These questions are not just academic, they go to the heart of our understanding of life and the universe. In trying to explain the paradox, scientists have proposed a variety of theories, ranging from the possibility that alien civilizations are intentionally avoiding us, to the idea that they simply aren't interested in communication. Some have suggested that advanced civilizations might have realized the dangers of exposing themselves to the universe, and so they have chosen to remain silent, perhaps hiding their presence to avoid attracting the attention of more hostile species. Others believe that civilizations might go through an evolutionary process in which they destroy themselves before they can achieve interstellar communication, either through war, ecological collapse, or the unintended consequences of their own technological advancement. Another theory is that we're simply not looking in the right way. Perhaps alien civilizations are using communication methods we cannot yet comprehend, or perhaps they are so far away that we're unable to detect their signals. It's possible that extraterrestrial civilizations are not using radio waves or electromagnetic signals at all, but rather some form of communication that we have yet to discover or understand. And so, we continue to search, hoping that one day we will find the key to unlocking the mystery. Despite the many theories and hypotheses, one thing is clear. The Fermi paradox is not just a scientific mystery, it's a philosophical one. It challenges our understanding of life, intelligence, and our place in the cosmos. If we are truly alone, what does that mean for us? What does it say about the nature of life itself? Are we destined to be the only intelligent species in the universe? Or perhaps more terrifyingly, are we simply one of the last to survive? The silence of the universe is not just an absence of sound. It's a reflection of the deeper, darker truths about life, the fragility of intelligence, and the vast, unknowable expanse of space. And as we continue to search for answers, we are forced to confront the uncomfortable possibility that the universe, in all its beauty and complexity, may not be as welcoming as we once hoped. The idea that we might be alone in the universe, or at least far more isolated than we had ever imagined, is unsettling in ways that reach deep into our sense of self and our place in the cosmos. We're not just asking whether we are alone, but why? What makes our planet, our solar system, and our very existence so unique in the grand expanse of space? If the universe is filled with billions of stars and planets, and life can emerge under a variety of conditions, why haven't we found other forms of intelligent life? To answer this, we turn to a theory that may offer a stark and disquieting possibility: the rare Earth hypothesis. The rare Earth hypothesis suggests that while microbial life, in its simplest forms, might be relatively common throughout the universe, complex life that can think, communicate, and build, is extraordinarily rare. In other words, Earth might be one of the very few, if not the only, planets in the universe where intelligent life has emerged. The idea proposes that the conditions required for complex life are so specific, so finely tuned, that the chances of those conditions being replicated on another planet are extremely low. Life might be widespread, but intelligent, complex life, the kind that can build civilizations, explore space, and wonder about its place in the universe, might be as rare as a needle in a cosmic haystack. At its core, the rare Earth hypothesis challenges a fundamental assumption that has been central to much of our thinking about the universe. For centuries, we've believed that the conditions that led to life on Earth, like the right combination of elements, the right temperature, and the right distance from a star, are not unique. We've thought that given enough time, life could emerge elsewhere in the universe under similar conditions. However, the rare Earth hypothesis flips this idea on its head, proposing that those conditions may not only be rare, but so finely tuned that Earth's combination of factors is an anomaly in the universe. Let's take a moment to think about what makes Earth so special in the context of life. For life to thrive as we know it, a number of conditions must align perfectly. First, there's the location of the planet. Earth sits in what is known as the habitable zone, a region around a star where conditions are just right for liquid water to exist on the surface. Too close to the star, and the heat would evaporate the water. Too far, and the water would freeze. Earth's position in this sweet spot where liquid water can exist is crucial for the development of life as we understand it. But the habitable zone is just the beginning. Beyond water, the planet needs the right chemical elements. The building blocks of life, such as carbon, nitrogen, oxygen, and hydrogen, must be abundant and easily accessible. Earth is particularly fortunate in this regard. It has an abundance of these elements in the right forms, allowing for the chemistry necessary for life to develop. In contrast, planets that lack these elements or have them in insufficient quantities may never see the emergence of life. Then there's the planet's atmosphere, which must be capable of supporting life. Earth's atmosphere provides oxygen for respiration, protects the surface from harmful radiation, and helps regulate temperature. The right combination of gases in the atmosphere is crucial to sustaining life. Without the right balance, conditions on a planet could be inhospitable to life as we know it. But the story doesn't end there. Earth also benefits from a protective magnetic field, which shields the planet from the harmful radiation of the sun and cosmic rays. The magnetic field is generated by the movement of molten iron in the Earth's core, a process that requires a planet of the right size, density, and composition. Without this magnetic shield, life on Earth would be far more vulnerable to solar and cosmic radiation. And there's one more piece of the puzzle that makes Earth conditions so exceptional: the presence of a large moon. Our moon plays a crucial role in stabilizing Earth's axial tilt, which in turn stabilizes our planet's climate. Without this stabilizing effect, Earth's climate could become erratic, making it much harder for life to thrive. In fact, many scientists argue that the presence of the moon is a critical factor in Earth's ability to support complex life. Taken together, these factors, our position in the habitable zone, the availability of key elements, a protective atmosphere, a magnetic field, and a stabilizing moon, create a set of conditions that are incredibly rare in the universe. In fact, when we consider the vastness of space and the number of variables that must align perfectly to support complex life, the rare Earth hypothesis suggests that the odds of all these factors coming together on another planet are staggeringly low. It's not just that these conditions are rare, it's that they are incredibly unlikely to occur in combination anywhere else in the universe. This is where the rare Earth hypothesis diverges from other theories of life in the universe. While many theories, like the idea of panspermia, the theory that life might spread across the galaxy via meteorites or comets, suggest that life could easily travel between planets or even across star systems, the rare Earth hypothesis argues that the emergence of complex life is an extraordinarily rare event, dependent on a unique combination of factors. It suggests that Earth is the exception, not the rule. The universe may be teeming with microbial life, but complex, intelligent life, life capable of building civilizations, creating technology, and exploring space, might be exceedingly rare. To further illustrate the improbability of intelligent life elsewhere in the universe, we need to consider the likelihood of life evolving to the point where it can communicate, develop technology, and engage in space exploration. The path from simple life forms to complex intelligent beings is long and fraught with obstacles. It's not just that life has to begin on a planet, it has to evolve over billions of years to produce intelligent creatures capable of abstract thought, problem-solving, and technological advancement. And this is a process that has occurred only once in the history of Earth, an event that took place over 3.5 billion years of evolutionary history. The complexity of this process suggests that the odds of intelligent life evolving on another planet, even if conditions are ideal, are vanishingly small. Moreover, even if intelligent life does emerge, there's no guarantee that it will survive long enough to achieve interstellar communication or exploration. The history of life on Earth is littered with mass extinctions, climate changes, and other catastrophic events that have wiped out species before they had the chance to reach the stars. So even if a civilization manages to achieve technological advancement, it might not survive long enough to explore the galaxy, let alone communicate with other civilizations. This too is a key part of the rare Earth hypothesis, a recognition that life, particularly intelligent life, is fragile, and that the conditions required for its survival are incredibly delicate. The rare Earth hypothesis paints a picture of the universe that is far lonelier and more isolated than we might like to believe. It suggests that Earth's unique combination of conditions may be a rare occurrence, one that is unlikely to be repeated elsewhere in the cosmos. This is not to say that life is impossible elsewhere, but rather that the kind of complex, intelligent life that we experience here on Earth might be an anomaly in the universe. The universe may be full of potential, but the likelihood that intelligent life exists elsewhere is far smaller than we once thought. If the rare Earth hypothesis is correct, it forces us to reconsider our place in the universe. It challenges our assumptions about the commonality of life and forces us to confront the possibility that we may truly be alone, or at least that the kind of life we know might be incredibly rare. And yet, even if this hypothesis is true, it also makes our existence all the more precious. We are not just one species among many in a bustling universe. We are potentially the sole bearers of intelligent life in the vast, dark expanse of space. The rarity of our existence only heightens the responsibility we have to safeguard our future and protect the delicate balance that has allowed life to thrive on Earth. As we look to the stars and continue our search for answers, the rare Earth hypothesis reminds us that the universe may not be as crowded as we once imagined, but it also challenges us to embrace the beauty of our uniqueness and to consider the extraordinary gift of life that we have been given. The silence of the universe, it seems, is not just an absence of voices, it is a reminder of how rare and fragile life truly is. The idea that intelligent life might be rare in the universe is a deeply unsettling one, particularly when we consider the vastness of space. For centuries, humanity has looked to the stars with the belief that if life exists, it must be plentiful. After all, with billions of stars and even more planets, the odds should be in favour of other civilizations. Yet, the more we search, the more we find silence. This silence, it seems, may not be the result of simply looking in the wrong places or being too early in our search. There might be a far more troubling explanation, one that has been hinted at by a concept known as the Great Filter. The Great Filter hypothesis suggests that there is a crucial barrier, a filter, that all civilizations must pass through to reach the point where they can communicate with others across space. This filter could be any number of things: a catastrophic event, a technological hurdle, or a societal flaw that prevents most civilizations from advancing far enough to achieve interstellar communication or travel. And the real question, the one that should keep us up at night, is whether the Great Filter lies behind us, in which case we may be one of the few civilizations that have made it past, or if it lies ahead of us, in which case our future could be just as precarious as the fates of countless civilizations that came before. The premise of the Great Filter is relatively simple. If there are billions of stars and potentially habitable planets scattered throughout the universe, and life is not an exceedingly rare phenomenon, then where are all the other civilizations? Why haven't we detected any signals? Why haven't we encountered any sign of intelligent life, despite the sheer scale of the universe? The Great Filter theory posits that the reason we haven't found other civilizations isn't because life is scarce. It's because most civilizations simply never make it to the point where they can communicate, explore, or travel between stars. They self-destruct, fail to adapt, or are wiped out before they have the chance to send their messages into the cosmos. The concept of the Great Filter doesn't just suggest that life is rare. It suggests that most life forms that reach the level of intelligence and technology necessary for interstellar communication face an almost insurmountable challenge. Whether it's environmental collapse, self-destruction through warfare, or an inability to overcome technological challenges, civilizations often fail to overcome this crucial obstacle. So, as we search the stars, what we might be witnessing is not the absence of life, but the aftermath of countless failed civilizations. The silence we hear may not just be the absence of others, it may be the sound of civilizations that didn't survive. Let's consider the possible stages of this filter. One possibility is that the filter exists early in the evolution of life. Perhaps the emergence of life itself is an exceedingly rare event, and the conditions required for life to begin are so specific that Earth may be one of the only planets where life has even emerged. This is the essence of the rare Earth hypothesis, the idea that life, particularly complex life, is extraordinarily unlikely to develop anywhere other than Earth. If this is the case, then the Great Filter might have already occurred, and we've made it through the toughest part. But while that is a comforting thought, it's far from certain. Another possibility is that the filter occurs after life has emerged, but before it can reach the point of developing advanced technology or interstellar communication. For example, many civilizations throughout history have faced significant environmental or ecological challenges. Climate change, resource depletion, or catastrophic events that have led to their downfall. Perhaps the Great Filter is an inevitable step in the development of life, one that occurs when a species fails to adapt to its environment or overreaches technologically. In other words, civilizations might inevitably reach a point where they destroy themselves through war, environmental collapse, or other forms of self-destruction. This scenario suggests that the Great Filter lies ahead of us, and that the reason we are still alone in the universe is that other civilizations never survived long enough to spread out into the stars. To illustrate the possible consequences of such a filter, we can look at the history of Earth itself. Throughout the planet's history, life has faced several near-extinction events: mass extinctions caused by asteroid impacts, volcanic activity, and climate shifts. These events wiped out a vast majority of species on Earth, and each time, life had to recover and evolve anew. But while life has persisted, it hasn't always led to the rise of complex, intelligent civilizations. The dinosaurs, for example, dominated Earth for millions of years, yet they never developed the level of intelligence or technology that we have. After the asteroid impact that caused their extinction, mammals were given the opportunity to rise and evolve, eventually leading to the emergence of humans. But this was no guarantee that intelligence would develop. It was a series of unlikely events that led to our species reaching the point of technological advancement and communication. In this light, the Great Filter becomes a sobering reality. For most species, the path to intelligence is not inevitable. There's no guarantee that any civilization will make it to the point where it can explore the stars or send messages into the void. Even if a species develops the capability for advanced technology, it might be undone by its own creations: nuclear weapons, environmental collapse, or other destructive technologies. The history of Earth is full of civilizations that have risen and fallen, and it may be that we too are on the verge of encountering a challenge that we cannot overcome. But what if the Great Filter lies ahead of us? What if we are currently on the brink of a critical point in our development, a point where we must face a monumental challenge that could determine whether we survive as a species or vanish like so many others before us? This is a terrifying thought, because it suggests that the silence we hear from the universe may not be a random occurrence. It may be a sign that intelligent civilizations, despite their potential, are doomed to destroy themselves before they can reach the stars. This raises the question: what is the Great Filter? What stands in our way? There are a number of possibilities, and we don't yet know which one is the most likely, but some of the potential barriers to our survival are already visible on the horizon. One of the most pressing concerns is climate change. Human activity has already led to significant changes in the planet's climate, and if we continue down this path, we could reach a point where the Earth becomes uninhabitable. Environmental degradation, resource depletion, and loss of biodiversity are all serious threats to the future of life on Earth, and they could be the very filter that prevents us from advancing beyond our planet if we cannot learn to adapt to our environment and manage our resources sustainably. We might find ourselves facing a collapse that could halt our progress. Another potential filter is nuclear war. The development of nuclear weapons has brought humanity to the brink of annihilation on several occasions. While the possibility of global nuclear conflict remains a looming threat, it also represents a challenge to our survival as a species. If we cannot find a way to coexist peacefully and avoid self-destruction, we might not live long enough to explore the stars. And then there's the technological filter. As we continue to advance technologically, we are increasingly faced with the question of whether we can control the technologies we create. Artificial intelligence, biotechnology, and other emerging technologies offer immense potential for progress, but they also come with significant risks. If we fail to manage these technologies responsibly, we could inadvertently create systems that lead to our downfall. The Great Filter is not a single event, but a series of challenges, any one of which could bring about the collapse of a civilization. And perhaps the greatest challenge of all is our ability to recognize these dangers and adapt to them. The reason we may be alone in the universe could be that most civilizations fail to recognize the risks they face until it is too late. The silence of the universe, then, might not be an accident. It could be a reflection of a hard truth, that the path to advanced intelligence and spacefaring civilization is fraught with peril, and that most civilizations, despite their potential, simply do not make it. The great filter stands in the way of progress, and it is a question we must confront as a species. If we want to survive, we must find a way to pass through that filter. The question is not whether we will encounter challenges, but whether we can overcome them, and if we cannot, we might be doomed to follow the same fate as countless civilizations before us. The search for life beyond Earth has been a fundamental part of human curiosity for centuries. For as long as we've looked to the stars, we've wondered if we are alone in the universe. From ancient myths and legends to modern science, the question of extraterrestrial life has captivated human imagination, prompting not only philosophical musings but also concrete scientific exploration. Our quest to answer this question has been anything but straightforward. It has been shaped by cultural beliefs, technological advancements, and evolving scientific understanding, each stage building upon the previous one in ways that have brought us closer to the answer, or perhaps further into the mystery. The earliest inklings of our search for extraterrestrial life can be traced back to ancient civilizations, though their methods were far removed from the rigorous scientific approaches we now employ. Ancient peoples often looked to the night sky with awe and reverence, seeing patterns and stories in the stars. They didn't just see points of light, they saw gods, creatures, and myths. Many cultures believed that the stars were the homes of gods or otherworldly beings, and they imagined that the heavens might be filled with beings far superior to themselves. These early beliefs weren't scientific in nature, but they did lay the foundation for our fascination with the idea that we were not the only intelligent life in the universe. One of the first ideas that brought the search for extraterrestrial life into a more scientific realm came from the ancient Greeks. Philosophers like Anaximander and Democritus speculated about the possibility of other worlds existing in the vast expanse of the universe. They questioned whether Earth was the only inhabited planet or if other celestial bodies might also harbour life. These early musings about the possibility of other worlds remained speculative and philosophical for many centuries, without any concrete evidence or mechanisms for testing the idea. It wasn't until the Renaissance, during the 16th and 17th centuries, that the search for life beyond Earth began to take on a more scientific approach. The invention of the telescope allowed astronomers to look deeper into the cosmos than ever before. Early astronomers like Galileo Galilei and Johannes Kepler began to wonder about the potential for life on other planets, especially as they discovered more about the nature of the universe. Galileo's observations of the moons of Jupiter, for example, led him to speculate about the possibility of other worlds with conditions that might support life. In the 19th century, the search for life beyond Earth began to take on a more modern form, fueled by scientific advancements in fields like biology, astronomy, and chemistry. During this period, astronomers began to take seriously the idea that life could exist elsewhere in the solar system. The discovery of canals on Mars by astronomer Percival Lowell in the late 1800s further sparked the imagination of the public and scientists alike. Lowell's observations, although later shown to be erroneous, were interpreted as evidence of artificial structures on Mars, possibly the work of an intelligent civilization. This idea captivated the public, and for a time the notion of Martians became a staple of popular science fiction and scientific discourse. The early 20th century saw the development of new theories about life in the cosmos. In 1920, astronomers, including the famous British scientist Sir James Jeans, proposed that there might be life on the moons of Jupiter and Saturn, where conditions might be suitable for life to develop. At the same time, the growing understanding of biology led scientists to hypothesize that life might not need Earth-like conditions at all. The discovery of extremophils, organisms that live in extreme environments on Earth, suggested that life could thrive in a variety of environments previously thought inhospitable. This discovery expanded the possibilities for where and how life could exist, not only in our solar system but also on planets and moons throughout the universe. One of the most significant moments in the history of our search for life came in 1961, when Frank Drake developed the Drake equation, a mathematical formula designed to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation took into account factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and the lifespan of technological civilizations. The equation provided a framework for thinking about the likelihood of extraterrestrial life, and while it remains speculative, it gave rise to a new era of research dedicated to finding intelligent life beyond Earth. The same year that Drake proposed his equation, the Search for Extraterrestrial Intelligence, SETI, was formally established. SETI's primary mission was to listen for radio signals from space, searching for signs of intelligent communication from alien civilizations. The idea was simple. If intelligent beings were out there, they might be using radio waves to communicate just as humans do. SETI's efforts have been ongoing for decades, scanning the skies with increasingly sophisticated technology, but so far they've yielded no definitive evidence of extraterrestrial intelligence. The silence, however, hasn't dampened the enthusiasm for the search. Instead, it has fueled the ongoing mystery of why we haven't heard from anyone yet. In the 1990s, the discovery of exoplanets, planets orbiting stars outside our solar system, opened a new chapter in our search for life. The first confirmed detection of an exoplanet came in 1992, and since then, thousands of exoplanets have been discovered. Many of these planets exist in the so-called habitable zone of their parent stars, where conditions might be right for liquid water to exist, an essential ingredient for life. The discovery of these exoplanets has brought us closer to finding Earth-like planets that could harbour life. The question now is not if there are other planets where life might exist, but whether those planets have life that is complex or intelligent. The search for biosignatures, chemical signs of life in the atmospheres of exoplanets, is an area of active research. Telescopes like the James Webb Space Telescope, set to launch in the near future, are expected to provide more data on the composition of exoplanet atmospheres and whether any signs of life might be detected. In addition to the search for life on other planets, our exploration of Mars has taken on greater significance in the quest for extraterrestrial life. Mars, with its ancient riverbeds, signs of past water activity, and seasonal methane emissions, has long been considered a prime candidate for harbouring microbial life. In recent years, missions like NASA's Curiosity rover and Perseverance rover have been exploring the Martian surface, searching for signs of ancient life. While definitive evidence of life has yet to be found, the ongoing exploration of Mars remains one of the most promising avenues for understanding whether life has ever existed beyond Earth. Yet, even as we have come closer to discovering planets with the right conditions for life, the silence of the cosmos remains. Despite our technological advances, despite decades of searching, we have yet to find direct evidence of intelligent extraterrestrial life. The discovery of microbial life on another planet or moon in our solar system would be a monumental step forward. But the question of whether intelligent life exists elsewhere in the universe continues to elude us. And perhaps, as unsettling as it may sound, that silence is telling us something deeper about the nature of life in the cosmos. The history of our search for life is a story of hope, discovery and perseverance. But it's also a story of the limits of our knowledge and the challenges of understanding our place in the universe. We have come a long way since the early musings of ancient philosophers, from myths about the gods in the sky to the scientific search for life across the stars. As we continue to explore the cosmos, we are confronted with the reality that we might not find the answers we are looking for. The question of whether we are alone in the universe is not one that can be answered easily, and as our search continues, we must ask ourselves, if we do find life, will it be the kind of life we expect? And if we don't, what does that tell us about the nature of the universe and our place within it? The journey is far from over, but the history of our search for life reminds us that the quest for answers is as much about the journey itself as it is about the destination. This search for extraterrestrial intelligence, or SETI, is one of humanity's most ambitious and profound scientific endeavours. At its core, SETI asks one simple but profound question. Are we alone in the universe? It's a question that has been with us for centuries, but only in the last few decades has the search taken on a more systematic scientific approach. Through radio telescopes, space missions, and computational models, SETI has become a symbol of human curiosity, the pursuit of knowledge, and the hope that we're not the only intelligent beings in the cosmos. SETI began in the 1960s with the work of astronomer Frank Drake. In 1960, he conducted what is widely considered the first modern SETI experiment, called Project Ozma, at the Green Bank Observatory in West Virginia. Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani, and listened for signals. This was a groundbreaking moment. For the first time, a scientist actively searched the stars for signs of intelligent life. Drake's experiment was rudimentary by today's standards, but it marked the beginning of an era of scientific exploration dedicated to the search for extraterrestrial life. The premise behind SETI is relatively simple. If intelligent civilizations exist in other parts of the universe, they might use radio waves or other electromagnetic signals to communicate with one another. These signals, if they exist, could travel vast distances across space, potentially reaching Earth. SETI researchers, using powerful radio telescopes, listen for these signals in the hope of detecting a pattern that could indicate the presence of an intelligent source. The idea is that natural processes, like the emission of radio waves by stars, would create random, noisy signals, while signals from intelligent civilizations might have a distinct pattern, something more deliberate, structured, or repeating. The first significant leap in SETI research came with the development of more sensitive and powerful radio telescopes. In the 1970s, projects like the search for extraterrestrial intelligence at the Arecibo Observatory began to scan a much larger portion of the sky. The Arecibo Observatory, which was located in Puerto Rico and operated until 2020, became one of the most important facilities for SETI research. It allowed scientists to listen to a vast range of radio frequencies and to search for signals from distant stars and galaxies. One of the most famous moments in SETI history came in 1977 when astronomer Jerry Eman, working on a SETI project at the Big Ear Radio Telescope in Ohio, detected a signal that became known as the WOW signal. This unexplained radio burst was a strong candidate for an extraterrestrial signal, but despite years of follow-up observations, it was never repeated or explained. The WOW signal remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. As technology advanced, so did the scope of SETI's search. In the 1980s and 1990s, the field saw the development of more sophisticated techniques for detecting potential alien signals. SETI researchers began to use supercomputers to analyze vast amounts of data more quickly and efficiently. The introduction of new radio observatories and the use of multi-wavelength astronomy, which included listening for signals in infrared, optical, and other parts of the electromagnetic spectrum, helped SETI move beyond just radio signals. Scientists started to explore the possibility that extraterrestrial civilizations might be using different forms of communication, including lasers or light pulses, to send messages across space. One of the major developments in SETI came with the launch of the SETI Institute in 1984, a non-profit organization dedicated to scientific research on extraterrestrial intelligence. The Institute began working on various initiatives, including the Allen Telescope Array, a large network of radio telescopes built specifically for SETI research. The Allen Telescope Array, located in Northern California, became an important part of the modern search for extraterrestrial signals, scanning thousands of star systems for signs of intelligent life. This array was designed to listen to multiple frequencies simultaneously, greatly expanding the search space. despite the decades of research and technological advancements, the search for extraterrestrial intelligence has, to date, yielded no conclusive evidence. No signals have been detected that could be definitively attributed to alien civilizations. This silence has led to growing questions about the nature of the universe and the challenges inherent in detecting extraterrestrial intelligence. Some, like the famous physicist Stephen Hawking, have cautioned that the silence could be a sign that intelligent life is rare, or even that civilizations self-destruct before they can communicate beyond their home planets. Others, like Carl Sagan, maintained that the vastness of the universe suggests that intelligent life is likely out there. It's just a matter of finding the right signals in the right places at the right time. In recent years, SETI has expanded beyond just searching for radio signals. Optical SETI, which focuses on detecting laser pulses from distant civilizations, has emerged as a complementary effort. Lasers, which can travel vast distances without scattering, may be a more effective means of communication for advanced civilizations. In addition, SETI researchers have begun to consider the possibility that extraterrestrial civilizations might be using other forms of communication entirely, such as quantum entanglement or neutrino-based communication. Methods that are still theoretical, but worth exploring as we expand our understanding of physics. The advent of new space telescopes, such as the James Webb Space Telescope, is expected to revolutionize the search for life beyond Earth. Unlike its predecessors, the Webb telescope is capable of observing distant exoplanets in greater detail, including their atmospheres. By studying the chemical composition of these planets' atmospheres, scientists hope to find signs of life, such as oxygen or methane, two gases that, on Earth, are often produced by living organisms. This represents a shift in SETI research, from looking for artificial signals to examining the conditions of planets that might support life. While this approach is different from traditional SETI, it is still part of the broader quest to understand whether we are alone in the universe. However, as we continue to search for extraterrestrial life, the silence remains. The Fermi paradox, the question of why, given the vast number of stars and planets, we have heard nothing, still looms large. Could it be that extraterrestrial civilizations are simply avoiding us, unwilling to make contact? Or is it that we are too early in our search, that we haven't developed the right tools or techniques to detect the signals? Perhaps the silence is a sign of something far deeper, that intelligent life is rare, and that we are, in fact, alone. As we move forward, the search for extraterrestrial intelligence will continue to evolve. New technologies, new theories, and new discoveries will shape the future of SETI. The search for alien life is no longer just about finding signals. It's about understanding the very nature of life, intelligence, and our place in the cosmos. Whether or not we ever find conclusive evidence of extraterrestrial civilizations, the journey itself has already expanded our knowledge of the universe, pushing the boundaries of science, technology, and philosophy. In the end, SETI is more than just a search for alien life. It's a search for meaning, for a deeper understanding of ourselves and the universe. It forces us to ask questions about what it means to be human and what our place is in the grand expanse of space. Whether or not we ever find another intelligent civilization, the search itself is an essential part of who we are, a reminder that, in the vastness of the universe, we're all searching for answers. Life, as we know it, is an incredibly delicate dance, a complex, finely tuned interaction between countless factors, forces, and events. Every living organism, every cell, every heartbeat is part of an intricate web that has evolved over billions of years. The existence of life is not the result of a single moment or a single element, but rather the outcome of countless variables that have aligned perfectly to create the conditions that allow life to flourish. The very fact that life exists at all is extraordinary, and when we look beyond Earth, the question we must ask is, how delicate is this dance really? How fragile is life, and what does that mean for our place in the cosmos? The Earth is uniquely suited to support life, but even here, the conditions for life are far from guaranteed. From the formation of the planet to the delicate balance of gases in our atmosphere, every detail of our existence is shaped by millions of years of evolution and cosmic events. Life on Earth is a result of an extraordinary confluence of factors, many of which had to happen in just the right way for life to emerge and continue to thrive. The temperature, the presence of liquid water, the right chemical elements, the protection from radiation, all of these factors must align perfectly for life to exist. And even then, life is fragile. Consider the countless species that have come and gone over the course of Earth's history. The planet has seen 5 major extinction events, each one wiping out the majority of life on Earth. These events, caused by catastrophic impacts, climate changes and volcanic eruptions, served as reminders of how tenuous life can be. After each extinction event, life has had to rebuild itself, starting from the most basic forms and slowly evolving into more complex organisms. Each time, Earth's ecosystems were reset, and the delicate dance of life had to begin again. But despite these setbacks, life has endured, evolving and adapting, surviving against the odds. This is the essence of the delicate nature of life. Life is not a foregone conclusion. It's not a process that is guaranteed to continue indefinitely. In fact, every step along the way, from the first single-celled organisms to the development of complex animals and plants, has been a fragile balancing act. The rise of intelligent life, of humans capable of shaping the world around them, is the product of this dance. It is the result of countless factors, each one influencing the next, building upon one another to create a civilization that can explore the universe and ask profound questions about existence. But the very fact that we are here, capable of asking those questions, is a testament to the fragility of life itself. When we look at the cosmos, we are reminded of just how rare this dance may be. The Earth, with its finely tuned conditions, might be one of the only places in the universe where life has had the opportunity to develop in such a complex way. While scientists continue to search for signs of life elsewhere in the universe, there's a growing recognition that life, especially intelligent life, may be much rarer than we once thought. The universe is vast, but the conditions necessary to support complex life might be incredibly rare. The delicate balance of factors that have allowed life to evolve on Earth may not be replicable on other planets, even if those planets have the necessary ingredients for life. The combination of the right distance from a star, the right temperature, the right chemical elements, and a stable environment is not something that can be taken for granted. The idea that life might be rare or even uniquely Earth-bound forces us to confront the fragility of our existence. It's a sobering thought, but it's one that makes us appreciate the delicate dance of life even more. It's easy to take life for granted, especially when we are immersed in the day-to-day realities of our world. We go about our lives, building our cities, creating technology, exploring the planet, and yet we rarely stop to think about how unlikely it all is. Every moment of our existence is the result of a perfect alignment of factors, a delicate dance of chance, circumstance, and time. But it's not just the conditions of life that are fragile. The way life evolves is also shaped by a delicate balance of forces. Evolution, the process by which life changes and adapts over time, is not a linear path. It's a series of twists, turns, and unpredictable events. Natural selection, genetic mutations, and environmental pressures all play a role in shaping life, and any small change in one of these factors can have profound effects on the course of evolution. For example, the asteroid that wiped out the dinosaurs was a cataclysmic event that changed the course of life on Earth forever. It opened the door for mammals to evolve and eventually give rise to humans. If that asteroid had never struck, or if it had struck a different part of the planet, life on Earth would have taken a completely different path. This idea of life being shaped by chance and circumstance is one of the most fascinating aspects of the delicate dance of life. While evolution follows certain principles, it is also influenced by randomness. The appearance of new species, the extinction of others, the emergence of new traits, these are all shaped by a combination of predictable and unpredictable forces. The future of life on Earth is similarly uncertain. While we have made incredible advancements in science and technology, we are still vulnerable to forces beyond our control. Climate change, natural disasters, and the potential for self-destruction are all threats that remind us of how fragile life can be. Just as life emerged through a delicate balance of forces, it could also be undone by the same forces. As we contemplate the possibility of life beyond Earth, we must ask ourselves, how likely is it that this delicate dance of life, with all its complexity and fragility, has happened elsewhere in the universe? If Earth's conditions are so rare, if life is such a delicate balance, then perhaps the universe is much emptier than we had hoped. Perhaps, in the vastness of space, the conditions for complex life are so rare that Earth is one of the few places in the universe where life has evolved into something capable of asking questions about the stars. If this is the case, the silence we hear from the universe may not just be a coincidence. It may be a reflection of the fragility of life itself. But this fragility also makes our existence all the more precious. It forces us to recognize that we are not just one species among many in a bustling universe. We are potentially the only intelligent life in the cosmos. The delicate balance that allowed us to evolve, that allowed us to reach this point in history, is something to be treasured and protected. Our future, as individuals and as a species, depends on our ability to recognize the fragility of life and to ensure that we do not undo the delicate dance that has brought us to this moment. The delicate dance of life is a reminder that life itself is rare, fragile, and incredibly precious. It's a dance that has taken billions of years to perfect, and it is a dance that requires balance, harmony, and a deep understanding of the forces at play. As we look to the stars, as we continue our search for life beyond Earth, we must remember that life is not a guarantee. It is a miracle, a rare occurrence in the vastness of space, and if we are lucky enough to find life elsewhere, we must recognize that it too is a delicate dance, a dance that may have taken just as many billions of years to perfect as our own. The search for life beyond Earth is not just about finding others. It is about understanding the fragility of life itself and the rare and precious gift that it is. The Goldilocks zone, often referred to as the habitable zone, is one of the most fundamental concepts in the search for extraterrestrial life. Named after the classic fairy tale of Goldilocks and the Three Bears, the zone describes the region around a star where the conditions are just right for life to exist. Not too hot, not too cold, but just the right temperature for liquid water to exist on a planet's surface. Water being one of the essential ingredients for life as we know it. While this may sound simple, the reality is far more complex, and the concept of the Goldilocks zone highlights just how unlikely life is to emerge on other planets, even when they seem to meet all the necessary criteria. The Goldilocks zone is determined by the star's characteristics. Stars of different sizes and temperatures emit varying amounts of radiation, which influences the range at which a planet could support liquid water. For a planet to fall within this zone, it must orbit its star at a distance where temperatures are stable enough for water to remain liquid, neither frozen solid nor boiling away into vapour. This makes the Goldilocks zone an essential starting point for considering whether life could exist on a planet. If a planet is too close to its star, it may be too hot, and any water on its surface would evaporate. Conversely, if it's too far from the star, the water could freeze, making the conditions inhospitable to life. However, this seemingly simple requirement, being within the Goldilocks zone, has far-reaching implications. It reveals just how narrow the window is for life to exist. The conditions that must be met are not just about temperature. They depend on a multitude of factors coming together in a delicate balance. A planet might be within the habitable zone, but that doesn't automatically make it suitable for life. Just as Earth is finely tuned to sustain life, so too must any other potentially habitable planet maintain a fragile equilibrium. And this balance is remarkably difficult to achieve. One of the most important factors influencing a planet's ability to support life is its atmosphere. The atmosphere serves as a protective shield, trapping heat through the greenhouse effect, maintaining a stable temperature and preventing harmful radiation from reaching the surface. Earth's atmosphere, composed primarily of nitrogen and oxygen, provides the perfect conditions for life to thrive. But if a planet has too thin of an atmosphere, or if it lacks the right composition, it could either freeze or burn its surface. On the other hand, a planet with an atmosphere that is too thick, such as Venus for instance, could trap excessive heat, creating a runaway greenhouse effect that would make life impossible. Moreover, the size and mass of the planet play an essential role in determining whether life could thrive. A planet needs to be large enough to maintain an atmosphere and hold on to the heat necessary to support liquid water. But if it's too massive, its gravity could be so strong that it could pull in harmful gases, or it could be subject to extreme geological activity that makes the surface unstable. Similarly, a planet must have the right chemical elements in its composition: carbon, nitrogen, oxygen, and other essential building blocks of life, distributed in such a way that they can support the development of complex organisms. Even small variations in a planet's composition can result in vastly different environments, which may or may not support life. Earth's position in the Goldilocks zone is no accident. It is the result of billions of years of cosmic evolution, with the right conditions aligning to allow life to develop. Our planet is not just at the right distance from the Sun. It also has a magnetic field that protects it from the harsh radiation of space, a stable orbit that keeps its climate relatively stable, and the geological activity needed to regulate the carbon cycle and maintain a livable atmosphere. The interplay of these factors is what makes Earth so uniquely suited for life. And yet, for all the perfection of Earth's environment, it's not guaranteed that other planets, even those in the Goldilocks zone, would have the same conditions. The balance that supports life is not only delicate, but exceedingly rare. When we begin to consider exoplanets, planets that orbit stars outside of our solar system, the concept of the Goldilocks zone becomes a key focus in the search for extraterrestrial life. Astronomers have discovered thousands of exoplanets in recent years, many of which are located within their stars' habitable zones. This has raised hopes that life may be out there, waiting to be discovered. However, just because an exoplanet is in the Goldilocks zone does not mean it's capable of sustaining life. As we've seen with Earth, it's the interaction of a host of factors: temperature, atmosphere, chemical composition, and geological stability that truly determines a planet's habitability. For instance, the presence of liquid water is essential for life as we know it. But water alone is not enough. The water needs to be stable on the planet's surface, not too hot to evaporate or too cold to freeze. Earth benefits from the right kind of water cycle: evaporation, condensation, and precipitation that helps regulate temperature and supports ecosystems. If an exoplanet has liquid water, but lacks the necessary conditions to sustain it in a liquid state, the planet could be incapable of supporting life. In addition to temperature and water, a planet's geological activity is another crucial element. Plate tectonics, the movement of the Earth's crust, plays an important role in regulating the carbon cycle, helping to maintain a stable climate over long periods of time. Without plate tectonics, a planet could experience extreme temperature fluctuations that might make life difficult, if not impossible. The Earth's internal processes, such as volcanic activity, also play a crucial role in maintaining the composition of the atmosphere by releasing gases like carbon dioxide, which helps to regulate the planet's temperature. A lack of such processes on an exoplanet could lead to an unstable atmosphere, making it difficult for life to thrive. This delicate balance is one of the reasons why Earth is so unique in the cosmos. While we have identified many exoplanets in the Goldilocks zone, most of them are still too distant or poorly understood for us to know whether they could actually support life. Even with advanced telescopes and observational techniques, detecting the signs of life or the potential for life on distant planets is a monumental challenge. The more we learn about what makes a planet truly habitable, the more we realize how much has to go right for life to emerge. The more we discover, the more we understand that life's existence may be an extraordinarily rare event in the universe. The search for life beyond Earth is not just about finding planets in the right zone. It's about understanding the intricacies of the Goldilocks zone and the other factors that must align for life to flourish. Every discovery of an exoplanet in the habitable zone is a step forward, but it also reinforces the realization that life, as we understand it, may be incredibly rare in the universe. The universe may be full of potential for life, but that life may exist only in a few rare corners where the balance of factors that sustain life can be found. And even in those rare corners, life might not always take the form we expect. So as we continue to explore distant worlds and search for life in the cosmos, we're reminded of just how remarkable Earth is. The Goldilocks zone, with its precariously narrow window of opportunity, is a reminder of how finely tuned the universe must be for life to emerge. It's a delicate dance of cosmic forces where the right conditions must come together in perfect harmony. Whether or not we find life elsewhere in the universe, the quest for understanding the Goldilocks zone reveals just how rare, precious, and fragile life truly is. The journey from microbes to minds is one of the most fascinating and complex stories in the history of life on Earth. It's a story that spans billions of years, from the first simple organisms that populated the planet to the rise of intelligent beings capable of creating technology, exploring the stars and pondering the mysteries of the universe. This progression, from single-celled organisms to sentient beings, has shaped our understanding of what life is and what it means to be alive. But as we look to the stars, we must ask, how likely is this journey to happen elsewhere? Is the emergence of intelligence, as rare and delicate as it seems, just another step in the natural progression of life? Or is it an extraordinary one-off event? The story begins with the most fundamental form of life, the microbe. Microorganisms, including bacteria and archaea, are the oldest forms of life on Earth. Evidence suggests that life began as far back as 3.5 billion years ago, when single-celled organisms emerged in the primordial oceans. These microbes were simple, single-celled organisms with no specialized structures or advanced capabilities. But they were remarkably resilient, able to adapt to a wide range of environments, from the deepest ocean trenches to the most hostile volcanic vents. They were, and still are, the backbone of life on Earth, performing essential functions such as photosynthesis and nitrogen fixation, processes that help sustain the planet's ecosystems. For billions of years, life on Earth remained microscopic, with evolution favouring simple organisms that could survive and reproduce in a wide range of environments. Over time, however, life began to evolve more complexity. Through a process known as symbiosis, different species of microbes started to form relationships with one another, leading to more complex cellular structures. Eventually, these simpler forms of life evolved into multicellular organisms, life forms composed of many cells working together, each with a specific function. This was the dawn of complexity. The transition from single-celled organisms to multicellular organisms was a pivotal moment in the history of life, and it paved the way for the evolution of the vast diversity of life forms that would come to inhabit Earth. Multicellular life forms allowed for the specialization of cells, which led to more complex organisms. Cells could now specialize in different tasks, like digestion, movement and reproduction, and together they formed tissues, organs, and eventually whole organisms. The first animals appeared around 600 million years ago, and they represented a new level of complexity in the evolutionary tree. Early animals, like the simple sponges and jellyfish, were still relatively simple, but they laid the groundwork for the evolution of more advanced organisms. Over millions of years, these early animals evolved into the vast array of life forms we see today, from fish to birds to mammals. The development of nervous systems marked a critical turning point in the journey to intelligence. Nervous systems allowed organisms to respond to their environment in more sophisticated ways, processing sensory information and coordinating actions to enhance survival. The first nervous systems likely appeared in simple organisms like jellyfish, who used basic nerve nets to control their movements. But it wasn't until the rise of vertebrates, animals with backbones, that nervous systems became more specialized, with the brain playing a central role in coordinating behavior and processing information. The evolution of the brain, and particularly the development of larger, more complex brains, was key to the rise of intelligence. Some animals, like dolphins, elephants, and certain species of birds, developed impressive cognitive abilities, such as problem-solving, social interactions, and communication. But it was the emergence of humans, and specifically the development of the human brain, that marked the apex of intelligence on Earth. The human brain is unique in its size, structure, and complexity. It's not just about the number of neurons or the size of the brain relative to body size, but the way the brain is organized and the ability it has for abstract thinking, language, and self-awareness. The development of intelligence was not a foregone conclusion in the history of life. Many species, despite having the necessary biological and environmental conditions to evolve, never developed complex cognitive abilities. The rise of intelligence was not inevitable, but the product of millions of years of evolution, driven by natural selection and shaped by countless factors, some predictable, others random. And yet, even though humans have achieved remarkable cognitive abilities, we are still far from the only intelligent life forms on Earth. Many other species, such as dolphins, whales, and some primates, exhibit forms of intelligence that are different from, but equally impressive to, our own. But intelligence, as remarkable as it is, comes with its own set of challenges. The human brain is an energy-hungry organ, consuming a significant portion of our caloric intake. This energy requirement likely explains why intelligence took so long to evolve. It's also one reason why other species, despite their evolutionary potential, may not have developed the same cognitive abilities. Evolution works not just by favouring organisms that are more intelligent, but by favouring those that can survive and reproduce in their environment. And intelligence, as beneficial as it can be, is costly in terms of energy and resources. As we look beyond Earth, the journey from microbes to minds takes on even greater significance. If Earth's evolutionary path is anything to go by, the emergence of intelligence requires more than just the right biological conditions. It requires millions of years of evolutionary pressure, the right environmental context, and a series of random events that favour the development of complex cognition. The path to intelligence, as we understand it, is not inevitable. It's a long, complicated, and rare journey that only a few species on Earth have successfully undertaken. When we look at exoplanets in the Goldilocks zone, we are forced to consider how rare the emergence of intelligence might be. A planet might have the right conditions for life: liquid water, a stable environment, the right chemical elements. But those conditions alone are not enough to ensure the evolution of complex life, let alone intelligent life. Even if microbial life exists elsewhere, the path to intelligence is not guaranteed. It could take billions of years for a planet's biosphere to evolve, from simple microbes to sentient beings, and many planets may never reach that stage. The journey from microbes to minds may be more complex, more improbable, and more fragile than we've ever imagined. This makes us question the possibility of finding intelligent life elsewhere in the universe. We might find microbial life on other planets, life that thrives in the subsurface oceans of moons like Europa or Enceladus. But the emergence of intelligence, of beings capable of abstract thought, technology, and space exploration, could be an incredibly rare event. If intelligence is not an inevitable step in evolution, if it's as fragile and unlikely as it seems, then perhaps we are far more alone in the universe than we once thought. The history of life on Earth, from microbes to minds, is a story of extraordinary complexity, chance and adaptation. It's a journey that has shaped the way we understand life and intelligence, and it forces us to ask profound questions about our place in the cosmos. The rise of intelligence on Earth may be the result of an incredibly rare combination of factors, and the more we explore the universe, the more we realise how fragile this process is. If intelligent life is as rare as it seems, then perhaps we're not just one species among many. We are, in fact, a very rare anomaly in the grand scope of the universe. And the search for other intelligent civilizations might be a search for something that, against all odds, may not exist anywhere else. The silence of the universe is one of the most profound and unsettling mysteries that we face as a species. For all our efforts to reach out into the cosmos, for all the technology we've developed to search for signs of extraterrestrial life, the universe remains eerily quiet. There are no messages, no signals, no signs of intelligent civilizations reaching out to us. The void is vast, and the silence is overwhelming. But what does this silence really mean? What are the implications of this isolation, and what does it tell us about our place in the universe? When we look at the night sky, we're confronted with the vastness of the cosmos, billions of stars, countless galaxies, and a seemingly infinite number of planets. Given the sheer number of stars and planets, the odds would suggest that life, and perhaps even intelligent life, should be abundant. Yet, despite decades of searching, we have not detected any definitive signals from extraterrestrial civilizations. This absence of communication is not just a technical challenge, it is a deeply philosophical one. Why is the universe so silent? Why, with all the potential for life, have we not heard from anyone? This silence forces us to confront the uncomfortable possibility that we may be truly alone in the universe. The implications of this isolation are profound. If we are alone, if intelligent life is as rare as it seems, then we must reconsider everything we thought we knew about our place in the cosmos. For centuries, humans have seen themselves as part of a larger cosmic community, imagining that life and intelligence were common features of the universe. Our search for extraterrestrial life has been fueled by the hope that we are not the only ones asking the big questions about existence, meaning, and the universe. But the silence of the cosmos suggests that we may be isolated in a way that we never imagined. If Earth is the only planet in the universe to harbour intelligent life, it forces us to re-evaluate our understanding of the universe itself. The cosmos, once seen as a bustling, teeming place filled with potential for discovery, becomes a cold and empty expanse. The idea of the cosmic neighbourhood, once so comforting, falls away, and we are left with the unsettling thought that we may be the only intelligent species in a vast, indifferent universe. This isolation also forces us to reconsider the nature of life itself. If intelligent life is as rare as it appears, then it raises the question of why life evolved the way it did on Earth. Was our emergence as an intelligent species simply the result of a series of lucky breaks? Or is there something inherent in the conditions of Earth that allowed for our unique form of life to develop? The rare Earth hypothesis, which posits that the conditions required for life are so finely tuned that Earth may be the only planet in the universe capable of supporting complex life, offers one possible explanation for our isolation. If this hypothesis is true, it suggests that we are an anomaly in the universe, a rare and fragile occurrence, rather than just one instance of a more common phenomenon. The silence of the universe also has profound implications for our future. If we are truly alone in the universe, if intelligent life is as rare as it seems, then we are the custodians of something incredibly valuable, the only known intelligence in the cosmos. This responsibility weighs heavily on us, as we are the stewards of not just our planet, but of the only form of life in the universe that we know of. Our actions, our decisions, and our survival are all intertwined with the fate of intelligence itself. The pressure to preserve life on Earth, to ensure that our species does not fall victim to the same fate as other failed civilizations, becomes even more urgent. The silence of the universe may be a reflection of the fragility of life itself, an echo that warns us of the dangers of self-destruction, ecological collapse, or technological misstep. The idea that we are alone in the universe also forces us to confront a deeper existential question. What does it mean to be human in a universe without other intelligences? For centuries, humanity has looked to the stars for meaning, for connection, and for a sense of purpose. The search for extraterrestrial life has been a way for us to explore not only the cosmos but also our own humanity. We've looked for life beyond Earth because we've hoped to find a mirror, something that reflects our own experiences, thoughts, and questions. But the silence of the universe suggests that perhaps there is no mirror, that we are, in a sense, alone in our search for meaning. This isolation has the potential to profoundly change the way we view ourselves. If we're truly alone, it means that the responsibility for the future of life, intelligence, and the pursuit of knowledge lies entirely with us. The absence of other voices, other perspectives may be lonely, but it also gives us an unparalleled opportunity to shape the future of the universe. We are the only ones who can ask the big questions and seek the answers. We are the only ones who can decide what happens next. The silence also highlights the fragility of life. As we search for other civilizations, we're reminded of how little we truly know about the universe. Despite all our advancements in science, technology, and exploration, we're still a relatively young species, and the universe remains a vast, mysterious place. The fact that we have not yet encountered other civilizations suggests that the path to intelligence is not an inevitable one, but rather a rare and fragile journey. We're not guaranteed to survive, nor are we guaranteed to make it beyond our planet. The silence is not just a cosmic void, it is a reminder that our existence, our intelligence, is a precious and fragile thing, and that we must work to preserve it. One of the most unsettling implications of the silent universe is the idea that the reason we are alone may be because intelligent civilizations do not survive long enough to make contact. This theory is tied to the concept of the Great Filter, which suggests that there is a critical barrier that prevents most civilizations from advancing beyond a certain point. Whether it's through self-destruction, environmental collapse, or failure to develop the necessary technologies, the Great Filter suggests that the reason we don't hear from other civilizations is because most of them never make it past a certain stage. If this is true, the silence of the universe may not just be a natural consequence of distance or timing, it may be a warning, a reminder that intelligence, even in its most advanced forms, is not invulnerable. The silence may also force us to reconsider our assumptions about life in the universe. If intelligent life is as rare as it seems, perhaps it's not just about the physical conditions of a planet or the biological processes that give rise to life. Perhaps, as some theorists suggest, there is something unique about the development of intelligence itself, something that is difficult to replicate. The emergence of consciousness, abstract thinking, and self-awareness may be such an unlikely event that it only occurs once in the universe, in a rare combination of circumstances. If this is the case, it suggests that the silence of the universe may not be a coincidence at all. It may be a reflection of the inherent rarity and fragility of intelligent life. The silent universe, then, forces us to confront the loneliness of our existence in ways that we have not fully considered before. We are alone in the vastness of space without any sign of others who might share our questions, our dreams, or our fears. But this isolation, while daunting, also presents an opportunity. It allows us to look inward and ask who we are, what we're capable of, and what we will become. It challenges us to understand the rarity and fragility of life, and to take responsibility for ensuring that the delicate dance of intelligence continues. The silence is not just a void, it is a call to action, a reminder that the fate of life, intelligence, and the future of the universe may rest entirely with us. The concept of the Great Filter has long been one of the most chilling ideas in the search for extraterrestrial life. It suggests that there's a critical barrier, an almost insurmountable challenge that prevents most civilizations from advancing beyond a certain point, whether it's reaching space, communicating with other civilizations, or simply surviving long enough to flourish. The question that haunts us now is, are we nearing it? Could humanity be standing on the precipice of a great existential obstacle, one that might prevent us from realizing our potential as a species and joining a broader galactic community? If the great filter is real, then the silence of the universe, the fact that we've heard nothing from extraterrestrial civilizations, may not be a random occurrence. It could be a signal that most civilizations like us fail to survive long enough to make their mark on the stars. The Great Filter is a theoretical explanation for the Fermi paradox. The question of why, given the sheer number of stars and planets in the universe, we have not yet encountered any signs of intelligent life. The paradox is simple. If the universe is so vast and life should theoretically be common, why do we hear nothing? If extraterrestrial civilizations exist, why don't we see evidence of them? Whether through radio signals, technological footprints, or even physical evidence. One explanation is that the Great Filter lies ahead of us, and it is the reason why we haven't heard from anyone else. Civilizations inevitably encounter a critical barrier, a fatal flaw that they cannot overcome, causing them to either stagnate or destroy themselves before they can achieve the level of technological sophistication required to communicate or travel across the stars. One possibility is that this barrier lies early in a civilization's development. For instance, the process by which life evolves from simple microorganisms to complex intelligent beings might be extraordinarily difficult. While life itself may be fairly common in the universe, the leap from simple, single-celled organisms to multicellular life, let alone to complex intelligent organisms like humans, could be a rare event. Earth may be one of the few planets where this leap occurred, and the Great Filter may lie in the early stages of evolution, where conditions must be just right for life to take its first steps toward complexity. Alternatively, the Great Filter could lie later, after a civilization reaches technological maturity. Imagine that a species achieves advanced technology, capable of space exploration or global communication, but then encounters a series of existential challenges: war, environmental collapse, the development of dangerous technologies, or an inability to adapt to changing circumstances. The Great Filter could be this point, when a civilization becomes so advanced that it has the tools to destroy itself, but it lacks the wisdom or ability to survive the perils of its own creation. This is where we may be headed, and it's an incredibly dangerous thought. It suggests that while humanity may have reached the stage where we can explore space, develop artificial intelligence, and potentially spread across the stars, we could just as easily fall victim to our own creations. This brings us to the possibility that we're already facing the Great Filter, and that it lies ahead of us. The technology and power we've gained over the past century have already made us vulnerable. We have developed weapons of mass destruction, environmental degradation, and technological systems that we may not fully understand or control. The rapid advancements in AI, biotechnology, and nuclear weapons present enormous risks, and while they offer the promise of solving some of humanity's greatest challenges, they also carry the potential for catastrophic failure. Could we be nearing the Great Filter right now? If so, it's not a distant problem we can postpone. It's an immediate threat that requires urgent attention. One of the most concerning aspects of the Great Filter is that we might not even recognize it when we encounter it. If the barrier is something that civilizations rarely overcome, perhaps because it's a crisis they don't anticipate or can't solve, then it may already be in motion without us even realizing it. Our world is full of complex and interconnected systems, from the environment to geopolitics to the global economy. If any of these systems begins to break down, it could trigger a cascade of consequences that might be difficult, if not impossible, to reverse. Climate change, resource depletion, and the threat of nuclear conflict are all issues that could lead to a tipping point, and once we reach that point, survival becomes increasingly uncertain. The Great Filter also raises a disturbing possibility that the barrier could be something inherent to the nature of advanced civilizations themselves. Perhaps intelligent beings are simply too prone to self-destruction. Historically, civilizations on Earth have collapsed or stagnated due to war, environmental degradation, or societal breakdown. As civilizations grow in power, they often face challenges in maintaining stability. Human history is full of examples of societies that flourished for a time but ultimately fell, whether through war, overexploitation of resources, or internal strife. If this pattern is universal, it would explain why we see no evidence of other civilizations. They either destroyed themselves before they could make contact, or they failed to advance beyond a certain point. In this light, the silence of the universe takes on a new, even more ominous meaning. The absence of extraterrestrial civilizations could be a sign that the Great Filter exists, and that most civilizations, perhaps even all of them, fail to reach the point where they can communicate across interstellar distances. If this is the case, the silence we encounter is not a random coincidence, but a grim reflection of a universal truth, that civilizations, no matter how advanced, face existential risks that most of them cannot survive. But even more unsettling is the possibility that we might be closer to the Great Filter than we think. If humanity has already reached the technological threshold where we are capable of self-destruction through nuclear warfare, environmental collapse, or the development of dangerous technologies, then the Great Filter might be something we're already approaching. Our ability to destroy ourselves is not a distant threat, but an immediate one. It's not just a hypothetical, it's a reality that we must grapple with as we face the risks of our own advancements. This realization forces us to confront our own future. If the Great Filter is ahead of us, then we are not guaranteed to survive the next stage of our development. The question we must ask ourselves is, can we overcome this challenge? Can we rise to the occasion, learn from the mistakes of past civilizations, and find a way to navigate the existential threats we face? Or will we, like so many civilizations before us, fall short and become another chapter in the silent history of failed species? On the other hand, there is a glimmer of hope in the idea that the Great Filter lies behind us. If humanity has already passed the most difficult hurdles, the challenges of evolving complex life, surviving early stages of technological development, and making it to a point where we can explore the stars, then perhaps we're among the lucky few civilizations that have made it. In this scenario, we might be on the cusp of something truly extraordinary, the opportunity to not only survive but to thrive in the galaxy. We could be one of the few species to have overcome the Great Filter and to have the potential to spread out into the universe, establishing a future where intelligent life flourishes. The Great Filter, whether it lies behind us or ahead of us, forces us to consider the fragility of civilization. It underscores the rare and delicate nature of intelligent life and the extraordinary challenges that all civilizations must face. Whether the filter is a biological, technological, or societal barrier, it reminds us that survival is never guaranteed. As we continue our journey into the cosmos, the Great Filter should serve as both a cautionary tale and a call to action. To take our responsibilities seriously, to recognize the risks we face, and to work together to overcome the obstacles that could otherwise doom us. Whether we are nearing the Great Filter, or whether we have already passed it, the challenge is clear. We must learn to navigate the fragile balance between progress and destruction, or risk becoming yet another silent casualty in the history of the universe. The history of life on Earth is punctuated by the rise and fall of civilizations, each one shaped by the forces of nature, human ambition, and the unpredictable tides of history. Across millennia, human civilizations have flourished, reaching heights of art, technology, and culture, only to fall into decline or collapse. Some collapses have been gradual, the result of internal decay or external pressure, while others have been abrupt, triggered by catastrophe or war. These civilizations, despite their achievements, ultimately did not last. And the lesson they teach is stark. Civilizations, no matter how advanced, are inherently fragile. The story of these civilizations offers a sobering perspective on the fate of intelligent life across the universe. Are we too doomed to follow the same path? Could this be the fate of every civilization, a universal pattern that ends in collapse? Throughout history, we've seen examples of civilizations that seemed unstoppable at their peak, only to crumble under the weight of their own complexities or external pressures. Consider the Roman Empire, a vast and powerful civilization that controlled much of Europe, North Africa, and the Middle East. At its height, the Roman Empire was a model of military might, cultural achievement, and technological innovation. Yet, despite its grandeur, the empire eventually succumbed to internal strife, economic troubles, and external invasions. It didn't fall overnight, but rather collapsed gradually over centuries, a slow unravelling of political, economic, and social structures that once held it together. The fall of Rome and the eventual fragmentation of Europe into smaller kingdoms marked the end of an era and the beginning of the Dark Ages. Another example of a civilization that didn't last is the Maya civilization of Mesoamerica. The Maya built monumental cities, developed a sophisticated understanding of astronomy, and created one of the most advanced writing systems of the ancient world. But by the 9th century, many of the great Maya cities were abandoned, their people scattered. While there is still debate among historians about the precise reasons for the collapse, the Maya civilization faced a combination of factors: environmental degradation, overpopulation, political instability, and prolonged droughts. What's striking about the Maya collapse is how advanced and seemingly resilient their society was, yet even they were unable to avoid the pressures that led to their downfall. Then there's the case of the Easter Island civilization, which is perhaps one of the starkest examples of a civilization's self-destruction. The island's inhabitants built the iconic Moai statues that are still a wonder of engineering and artistry today. However, the people of Easter Island, through deforestation and over-exploitation of their resources, eventually destroyed the very environment that sustained them. The collapse of Easter Island's civilization wasn't the result of invasion or external forces, but of ecological collapse driven by human activity. The lessons of Easter Island are particularly poignant because it serves as a reminder of how fragile civilizations can be when they overstep the limits of their environment. What these civilizations share, despite their differences in time, geography, and culture, is the fact that their decline was not inevitable. It was driven by a combination of internal and external factors that accumulated over time. They were unable to overcome the challenges they faced, and they ultimately collapsed under the weight of those challenges. This raises a disturbing question. If civilizations, even those as powerful and advanced as the Romans or the Maya, can fail, what does that mean for our own civilization? For humanity, the idea that our civilization might not last is a deeply uncomfortable thought. After all, we have made incredible strides in technology, science, and culture. Our civilizations have reached unprecedented levels of global interconnection, and we have the power to shape the future in ways that no civilization before us could have imagined. Yet, despite these advancements, our civilization faces many of the same challenges that led to the collapse of past civilizations. We live in a world marked by environmental degradation, political instability, economic inequality, and technological risks. We face challenges: climate change, resource depletion, nuclear proliferation, that could potentially lead to a collapse just as they did for past societies. The question is not whether we are immune to these risks, but whether we can learn from history and adapt in time to prevent our own downfall. One of the key reasons civilizations fail is the inability to adapt to changing circumstances. The collapse of complex societies often occurs when a civilization's institutions, cultures, and technologies no longer provide the solutions they need to survive in an evolving world. The Romans, for example, were unable to cope with the growing pressures on their empire. External invasions by barbarian tribes, economic crises, and political fragmentation. Similarly, the Maya were unable to manage their agricultural practices in the face of prolonged droughts. Civilizations, no matter how powerful, are vulnerable to environmental, political, and economic changes, and once the pressures become too great, they often fail to adjust quickly enough to prevent collapse. Another common theme in the collapse of civilizations is resource depletion. As societies grow, they often exploit natural resources at unsustainable rates. The people of Easter Island, for example, cut down their forests to build moai statues and construct canoes. Over time, the loss of trees led to soil erosion, which diminished their agricultural capacity, ultimately leading to famine and societal collapse. The same phenomenon can be seen in more modern civilizations, where industrial growth, deforestation, overfishing, and the burning of fossil fuels have created ecological imbalances that threaten the stability of our own societies. As resources become scarcer, societies become more vulnerable to collapse. In addition to these environmental pressures, civilizations often struggle with internal divisions, political instability, social unrest, and inequality. The decline of the Roman Empire was not just due to external threats, it was also shaped by a growing divide between the ruling elite and the common people, corruption, and a loss of civic engagement. As societies become more complex, they often face increasing challenges in managing internal divisions. This can lead to the weakening of political institutions, the erosion of social cohesion, and the collapse of the social contract that holds societies together. Perhaps the most frightening aspect of this pattern is that many civilizations didn't see their decline coming. They were too entrenched in their systems to recognize the warning signs until it was too late. This is the greatest risk that modern civilization faces. We may be so absorbed in our technological and economic progress that we fail to see the environmental, social, and political risks we face. The collapse of past civilizations was often not the result of a single catastrophic event, but rather a series of small, incremental changes that built up over time. Once those changes reached a tipping point, however, the collapse became inevitable. So what can we learn from civilizations that didn't last? The most important lesson is that no civilization, no matter how powerful, is invincible. It's easy to think that the advancements of modern technology, science, and global interconnectedness make us immune to the forces that caused the fall of previous civilizations. But the truth is, we are still subject to the same fundamental pressures: resource depletion, environmental destruction, political instability, and the risk of technological overreach. The challenge for us is not just to recognize these risks, but to address them proactively before it's too late. The collapse of civilizations throughout history is a sobering reminder of how fragile human societies can be. It forces us to ask difficult questions about our own future. What steps are we taking to protect our civilization from collapse? Are we learning from the mistakes of those who came before us? Are we creating systems that can adapt to the challenges of the future? Or are we pushing ourselves toward a point of no return? Ultimately, the fate of civilizations is shaped not just by their achievements, but by their ability to adapt, to recognize the limits of their growth, and to act decisively in the face of existential threats. As we look to the future, we must remember the lessons of the past. Civilizations that don't last are often those that fail to see the warning signs, those that push too far without considering the consequences. If humanity is to avoid the same fate, we must learn from the collapses of the past and work together to create a sustainable, resilient future, one that can withstand the pressures of our time and ensure that we don't follow the same path of destruction that so many others have tread before us. Technological development has been one of the driving forces behind humanity's progress. It has transformed our societies, expanded our reach, and revolutionized our understanding of the world and the universe. From the invention of the wheel to the creation of the internet, Technology has allowed us to overcome the limitations of biology and the physical world. It has brought us closer to understanding the cosmos, improved the quality of life for billions, and given us the power to connect in ways once unimaginable. But with every blessing comes a curse, and the more advanced our technology becomes, the more it challenges our capacity to control it. The fundamental question we face as a species is whether technology will be our salvation or our undoing. Can we wield the tools of our creation responsibly, or will our inventions spiral out of control and lead us to catastrophe? While technology has the potential to solve some of humanity's most pressing problems, it also presents unprecedented risks that we must confront head-on. As we continue to push the boundaries of what is possible, we must ask ourselves, is our technological progress outpacing our ability to manage it? The most immediate example of technology's dual nature can be seen in the development of nuclear weapons. The atomic bomb, created during World War II, was an incredible scientific achievement, the culmination of decades of research in physics and engineering. Yet, the same technology that has the potential to deliver unimaginable power and progress also holds the capacity for unparalleled destruction. The bombings of Hiroshima and Nagasaki were a testament to the devastating potential of nuclear weapons, and the threat of nuclear war remains one of the greatest dangers facing humanity today. Despite decades of efforts to curb nuclear proliferation, the reality is that there are still thousands of nuclear weapons in existence, many of them far more powerful than the bombs dropped on Japan. The very existence of such weapons is a constant reminder of how our technological progress can become a threat to our survival. The development of artificial intelligence, AI, presents another example of the double-edged sword of technology. On one hand, AI has the potential to revolutionize fields such as healthcare, transportation, and education. It promises to solve complex problems, optimize processes, and create efficiencies that were once unimaginable. But AI also poses significant risks. As AI systems become more advanced, they could surpass human intelligence, leading to concerns about control, autonomy, and ethical considerations. What happens when machines become smarter than the people who created them? Could they one day act in ways that are detrimental to humanity's interests? The rapid development of AI raises fundamental questions about the future of work, power, and decision-making, and whether we can ensure that these technologies remain aligned with our values and interests. The internet, too, exemplifies the complexities of technological progress. On one hand, it has connected the world in ways that were previously unimaginable, allowing for the free exchange of ideas, information, and culture. It has democratized access to knowledge, provided platforms for marginalized voices, and made it possible for people to connect across vast distances. But the internet has also given rise to a host of problems: privacy issues, misinformation, cybercrime, and the erosion of traditional social structures. The internet, which was once seen as a tool for enlightenment, has become a breeding ground for division, hatred, and manipulation. Social media platforms, in particular, have exacerbated the spread of false information, creating echo chambers that reinforce biases and divide societies. The rise of surveillance capitalism, where personal data is harvested and sold for profit, has raised concerns about privacy, autonomy, and the commodification of our lives. The environmental impact of technological development is another area where the blessings of progress come with significant costs. Industrialization, powered by advances in technology, has been a driving force behind the global economy, leading to greater productivity and improved living standards for billions of people. Yet, the environmental costs of this progress have been staggering. The burning of fossil fuels, deforestation, and pollution have caused irreparable damage to the planet's ecosystems and accelerated the pace of climate change. The very technologies that have allowed us to build modern civilization have also contributed to the degradation of the environment that sustains us. As we push forward with new technologies, such as geoengineering, artificial intelligence, and genetic modification, we must consider whether the potential benefits outweigh the environmental costs. Even in the realm of medicine, where technological development has undoubtedly saved millions of lives, there are ethical dilemmas to confront. Advances in genetics, biotechnology, and medicine have allowed for the treatment of diseases that were once considered incurable. Yet, these same advancements have raised questions about the limits of human intervention in the natural world. The possibility of genetic modification, cloning, and designer babies has sparked debates about the ethics of playing God and the potential for unintended consequences. How far should we go in altering the genetic makeup of life? Can we balance the desire for medical advancement with the responsibility to avoid unforeseen harm? The rapid pace of technological development has outstripped our ability to fully understand and regulate its consequences. Every new technology brings with it the potential for both immense progress and profound danger. In many cases, the full implications of these technologies are not immediately apparent, and by the time we understand the risks, it may be too late to prevent harm. For example, the widespread use of plastics revolutionized manufacturing, but it has also created an environmental crisis, with plastic pollution now threatening oceans, wildlife, and human health. Similarly, the advent of the automobile transformed society, but it also led to environmental damage, traffic accidents, and the development of sprawling, unsustainable urban environments. This constant tension between the promise of technology and its potential for destruction raises important questions about our future. As we continue to develop new technologies, we must ask ourselves how we can ensure that these advancements are used for the benefit of humanity and the planet, rather than leading us down a path of self-destruction. How can we manage the risks of AI, genetic engineering, and nuclear weapons, while still harnessing their potential to improve the human condition? And most importantly, how do we develop a global framework for ethical decision-making in a world where technological advancements are often moving faster than our ability to understand or regulate them? The answer, it seems, lies in our ability to govern our technology responsibly. We must recognize that technological progress, while transformative, must be balanced with caution, foresight, and ethical consideration. Governments, international organizations, and the global community must work together to establish regulations and safeguards that prevent technology from being used recklessly or irresponsibly. At the same time, individuals must consider the ethical implications of the technologies they use and the choices they make. Technological development can be both a blessing and a curse, depending on how we choose to wield it. It is up to us to ensure that the technologies of tomorrow serve the common good, rather than becoming tools of destruction. In the end, technology is not inherently good or bad. It is a reflection of us, our values, our choices, and our capacity for both creation and destruction. The challenge for humanity is not just about developing new technologies, but about understanding their full implications and using them responsibly. As we look toward the future, we must recognize that the true measure of our success will not be in how much technology we create, but in how we use it to build a better, more sustainable world. The future of humanity, for better or worse, will be shaped by the choices we make today in the face of technological progress. The universe is a place of staggering scale, filled with galaxies, stars, and planets that have been born, evolved, and died across billions of years. Yet despite the vastness and the countless opportunities for life to emerge, the history of the cosmos is one of constant change, cataclysmic events, and the inevitable end of things. From the birth and death of stars to the collision of galaxies, the universe is governed by forces of creation and destruction. For every new beginning, there is an inevitable end. And for life to persist, whether on Earth or elsewhere in the universe, it must contend with this ceaseless cycle of extinction and rebirth. The idea of a universe shaped by extinction events is not just a metaphor, it's a scientific reality. The history of life on Earth is a testament to the destructive forces that have shaped our planet. Over the course of Earth's history, there have been 5 major mass extinction events, each one wiping out the majority of life on the planet, dramatically reshaping the course of evolution. These events, ranging from the extinction of the dinosaurs to the extinction of early marine life, have been caused by a variety of factors, from asteroid impacts to volcanic eruptions and climate shifts. Each time, life on Earth was forced to rebuild and adapt, starting anew from the few survivors. But the universe itself is no stranger to extinction events. In fact, the entire cosmos is shaped by the death of stars, the collision of galaxies, and the eventual decay of celestial bodies. Stars are born, live out their brief lives, and then die in a spectacular explosion of light and energy, a process known as a supernova. These events, while destructive, are also necessary for the creation of new elements and the formation of planets and life. But the death of a star is not a singular event. It marks the end of one phase of the universe's evolution and the beginning of another. The remnants of dead stars, black holes, neutron stars, and white dwarfs, remain as haunting reminders of the cosmic cycle of creation and destruction. Our own solar system is not immune to this cycle of death and rebirth. The Sun, a middle-aged star, will eventually run out of fuel, swelling into a red giant before shedding its outer layers and leaving behind a white dwarf. In the distant future, this process will render Earth uninhabitable, as the Sun's increasing heat will strip away the atmosphere and boil away the oceans. In a sense, our planet's fate is already sealed. While this might seem like a distant event, billions of years away, it underscores the inevitability of extinction. The universe, by its very nature, is a place of impermanence, where everything, whether living or inanimate, is subject to the forces of decay and destruction. Even on a larger cosmic scale, the universe is destined for a dramatic end. The fate of the universe itself is one of uncertainty, but most cosmologists agree that it will eventually face an end, though the form that end will take is still a matter of debate. There are several theories, each as dramatic as the last. The Big Freeze suggests that as the universe continues to expand, galaxies, stars, and eventually planets will drift so far apart that the universe will become a cold, empty void, incapable of supporting any form of life. The Big Crunch theorizes that the expansion of the universe will eventually reverse, causing everything to collapse in on itself, leading to a catastrophic, universe-wide implosion. The Big Rip predicts that the universe will continue to expand at an accelerating rate, eventually tearing apart galaxies, stars, planets, and even atoms in an ultimate cosmic disintegration. The universe's extinction events are not just the result of physical processes, they're also driven by the laws of entropy. Entropy, the tendency of systems to move from order to disorder, is a fundamental principle of thermodynamics. Over time, the universe will lose its ability to sustain complex systems, including life. Stars burn through their fuel, galaxies collide and merge, and matter is gradually spread out across the universe, moving toward a state of greater disorder. Eventually, the universe will reach a state of maximum entropy, a time when all matter is evenly distributed and no further work can be done. This final state, often referred to as heat death, would render the universe lifeless, a cold, still place where no processes of creation or destruction can occur. While the universe itself seems destined for one form of extinction or another, the question remains, what does this mean for life, both on Earth and beyond? If extinction is an inherent part of the cosmic cycle, how does life persevere? How does life, whether microbial or intelligent, survive in a universe marked by so much destruction? The answer may lie in our ability to adapt and evolve. Life on Earth has survived countless cataclysmic events. The Permian-Triassic extinction, the largest mass extinction in Earth's history, wiped out over 90% of species on the planet. Yet life rebounded, adapting to the new environment and evolving into new forms. The Cretaceous Paleogene, KT extinction, which wiped out the dinosaurs, paved the way for the rise of mammals and eventually humans. The resilience of life in the face of such events is a testament to its ability to adapt, evolve, and survive even in the harshest of circumstances. But this resilience does not mean that life is invulnerable. The fragility of life is evident in the fact that so many species, including entire ecosystems, have been wiped out by the forces of nature. The extinction of the dinosaurs was a result of an asteroid impact, a cosmic event that changed the course of evolution on Earth. If such an event were to happen again, it could be enough to wipe out human civilization and all life on Earth. Even without an asteroid impact, humanity faces numerous existential threats, from climate change to nuclear war to global pandemics, that could trigger our own extinction. While we have the ability to shape our environment and protect ourselves from some of these threats, the reality is that life, even advanced life, remains vulnerable to the forces of the universe. In the search for extraterrestrial life, these questions of survival and extinction take on even greater significance. If life is common in the universe, why haven't we found any signs of intelligent civilizations? Could it be that most civilizations face the same existential risks that we do, and that they fail to overcome them before they can make their mark on the cosmos? The absence of extraterrestrial life may not be a sign that life is rare, but that the path to interstellar civilization is fraught with peril. Civilizations may rise, but they often fall, either by their own hand or by forces beyond their control. The search for extraterrestrial intelligence, SETI, is, in many ways, a search for answers to these questions. If other civilizations exist, what can we learn from them? Have they faced the same extinction events that we are likely to encounter, and how have they responded? If we are truly alone, it may mean that the journey to intelligence and spacefaring civilization is one of extraordinary fragility. Even in the vastness of the universe, where countless stars and planets exist, intelligent life may be extraordinarily rare, because civilizations rarely survive long enough to reach the stars. The universe is a place of creation and destruction, of life and death, of beginnings and endings. The extinction events that shape the cosmos are not just physical phenomena, they are a reminder of the impermanence of all things. They force us to confront the fragility of life and to question whether humanity, or any civilization, can survive in the face of the inevitable forces that govern the universe. The challenge for us as a species is not only to survive, but to find a way to adapt, evolve, and thrive in a universe marked by extinction. Whether on Earth or beyond, the future of life will depend on our ability to navigate the forces of destruction and to secure our place in the cosmos before it's too late. The vastness of the cosmos, with its endless expanse of stars, planets, and galaxies, can evoke a sense of wonder and awe. Yet for all its beauty and grandeur, there's an underlying feeling that often accompanies the contemplation of the universe: loneliness. As we look up at the night sky with its billions of stars, we are confronted with the silence of the universe, the absence of other voices, other beings. The vastness of space seems to highlight our isolation, our smallness in an immense, indifferent universe. This feeling of loneliness is not just a physical or geographical one, but a philosophical one. It forces us to confront our place in the cosmos, our significance, or lack thereof, and our existential position as perhaps the only intelligent beings in an otherwise silent universe. This philosophy of loneliness is one that has been explored by thinkers, scientists, and writers for centuries. It is a theme woven into much of our literature, art, and philosophy, particularly as we grapple with the question of whether we are truly alone in the universe. The search for extraterrestrial life, in many ways, is a search for companionship in the vast isolation of space. We want to know that we are not alone, that the questions we ask about existence, meaning, and consciousness are shared by others in the universe. But the longer we search, the more we are confronted with silence, and the silence is deafening. It forces us to confront the unsettling possibility that we might be alone, not just for now, but forever. In some ways, loneliness in the cosmos is rooted in the Fermi paradox, the question of why, given the vast number of stars and planets in the universe, we have not yet encountered any evidence of extraterrestrial civilizations. If life is common, if the conditions for life are so widespread across the cosmos, why is the universe so silent? The absence of other intelligent beings, despite the vastness of space, suggests that perhaps we are the exception rather than the rule, and if we are alone, this has profound implications for our sense of meaning and purpose. Are we just a fluke of evolution, a random occurrence in a universe that is otherwise empty of conscious life? Or is there a deeper meaning to our existence, one that we must discover within ourselves, rather than looking to the stars for answers? One of the central philosophical implications of the loneliness in the cosmos is the question of our significance. In a universe that is incomprehensibly large, we are just a tiny speck, an insignificant dot on the cosmic scale, and yet we are capable of questioning our existence, pondering the nature of life, and searching for meaning. If no other intelligent beings exist in the universe, then all of the hopes, dreams, and ambitions of humanity are uniquely our own. Our thoughts, our achievements, our understanding of the universe are the products of a solitary species, potentially the only one capable of contemplating such questions. This brings into focus the paradox of human existence. We are both incredibly small in the grand scheme of the cosmos, and yet, in our consciousness and ability to reflect on the universe, we're uniquely significant. The concept of existential loneliness goes beyond the mere fact that we might be alone in the universe. It touches on the deeper sense of isolation that comes with being aware of our own existence. As humans, we are self-aware. We understand that we exist, and we question why we exist. This awareness can bring about a profound sense of solitude. The realization that there may be no one else out there to share this awareness with can be a deeply unsettling thought. It forces us to confront the possibility that our experience of existence is unique, and that we may be the only sentient beings to ponder the very nature of life, death, and the universe. This existential loneliness is something that many philosophers have grappled with, from Jean-Paul Sartre's musings on the human condition to Albert Camus' exploration of the absurdity of existence. For Camus, the universe is indifferent to our suffering, and the quest for meaning in an uncaring cosmos is a fundamental part of the human experience. The loneliness of the cosmos is tied to this sense of absurdity, the idea that despite our search for meaning, the universe offers no answers, only silence. But there is a certain comfort in the fact that loneliness in the cosmos is not necessarily a final, bleak conclusion. In fact, this sense of isolation can be a source of empowerment. The realization that we are alone in the universe, if it proves true, might challenge us to create our own meaning, to build our own purpose, rather than relying on the existence of other beings to validate our existence. This idea is embodied in the concept of existentialism, which asserts that we are responsible for creating our own meaning and finding purpose within the confines of our own lives. In a universe that may be indifferent to our existence, we have the power to shape our own destiny and make our lives meaningful. Furthermore, loneliness in the cosmos can inspire a sense of wonder and a deeper appreciation for life itself. The realization that we may be the only ones capable of contemplating the stars gives weight to the responsibility we have as stewards of our planet and civilization. If we are alone, if the future of intelligent life rests on our shoulders, then it is all the more important for us to preserve life, to protect our environment, and to ensure that the flame of consciousness and curiosity continues to burn. Our loneliness in the cosmos could drive us to be more thoughtful and intentional in how we live our lives, how we treat others, and how we seek out knowledge. It may prompt us to explore the mysteries of the universe with greater urgency, knowing that we may be the only species capable of such exploration. Moreover, the search for extraterrestrial life, though it may have led to frustration and disappointment in the face of silence, is also a reflection of our fundamental desire to connect. Our longing for connection with other beings is rooted in our shared experience of loneliness. The search for alien life is, in many ways, a search for companionship, someone to share in the questions we have about existence, purpose, and meaning. If we are indeed alone, then it becomes all the more crucial for us to find meaning in our own relationships, in our communities, and in our understanding of the world. The loneliness of the cosmos might push us to look inward and to recognize the value of the connections we already have with one another. While the loneliness of the cosmos may initially seem bleak, it also offers profound opportunities for reflection and growth. It challenges us to face the reality of our isolation, but also inspires us to create our own meaning in a universe that offers none. The silence of space is not necessarily an indication of despair. Rather, it can be a reminder of the incredible opportunity we have to shape our own destiny, to forge our own path, and to find significance within our own lives. Whether or not there is life elsewhere in the universe, the search for meaning will remain a deeply human endeavour. The philosophy of loneliness in the cosmos forces us to confront the deepest questions of existence, and in doing so, it offers us the opportunity to define our place in the universe on our own terms. The question of whether life exists elsewhere in the universe has captivated humanity for centuries. We've looked to the stars, sending out signals, building telescopes, and launching probes in the hope of finding signs of alien life. The silence we encounter, however, has led many to believe that life in the universe may be rare, perhaps even unique to Earth. But what if that assumption is wrong? What if life is not as rare as we think, but simply elusive, hidden in places or forms we cannot yet comprehend? What if life is common throughout the universe, but we've just missed it? This question turns the traditional search for extraterrestrial life on its head. Most of our efforts to find alien life have been based on the assumption that life, at least intelligent life, should be detectable in ways we understand. We look for planets in the Goldilocks zone, where conditions are just right for life, and we listen for signals from intelligent civilizations. We search for familiar markers, water, oxygen, methane, as signs of life, believing that extraterrestrial life, if it exists, will share many of the same characteristics as life on Earth. But what if we're limiting ourselves? What if the life we seek is not like anything we've imagined, and our methods of detection are simply too narrow? The rare Earth hypothesis suggests that Earth's conditions may be unique, and that intelligent life in particular is extremely rare in the universe. It posits that the combination of factors that allowed Earth to host life is so finely tuned that the chances of finding another planet with those same conditions are exceedingly low. While microbial life may be common, the conditions needed for complex intelligent life could be so specific that they only occurred on Earth. This idea has driven much of our thinking about the search for alien life. But what if we've misunderstood the nature of life itself? What if life isn't as fragile or unique as we think, but simply takes forms we haven't yet encountered or can't yet recognize? One possibility is that life exists in forms that are completely different from anything we've encountered on Earth. We tend to assume that life, wherever it exists, will be carbon-based and need water to survive. This is based on the fact that all known life on Earth is carbon-based and relies on water. But there's no reason to believe that life must adhere to these principles. Silicon, for example, is another element that can form complex molecules, and some scientists speculate that life could be based on silicon rather than carbon. There are also theories suggesting that life could exist in environments vastly different from Earth's, such as the hot, high-pressure environments of Venus, or the frozen, methane-rich worlds of Saturn's moon Titan. Life could be thriving in places we haven't yet considered, and we simply don't have the tools or imagination to recognize it. We also tend to look for life that is similar to ours, life that is complex, multicellular, and capable of communication or technological advancement. But this narrow focus on intelligent life could blind us to the possibility of other, simpler forms of life. There could be microbial life on Mars, Europa, or Enceladus, but our current methods of searching may not be sensitive enough to detect it. Microbial life is far more difficult to detect than intelligent life, and we may be overlooking it because we're looking for the wrong signs. We might be looking for radio signals, for example, when we should be focusing on biochemical signatures or other indirect signs of life that could be much more subtle. If life is common, it could be thriving in forms we've never imagined, and we might be missing it because we're not looking in the right way. One possibility that has gained increasing attention in recent years is the idea that life may be widespread in the universe, but we simply haven't been searching for long enough. The universe is vast, and even the most advanced telescopes and probes have only scratched the surface of what is out there. The search for extraterrestrial life is still in its infancy, and many scientists believe that we may not have yet developed the technology or the methods to detect it. We've been searching for signs of life for a few decades, but compared to the age of the universe, billions of years, that's a mere blink of the eye. Life could be abundant, but we may not have yet reached the technological threshold needed to detect it. We might be living in an era of cosmic adolescence, and the future of space exploration could reveal life in places we never thought to look. What if we've also missed life due to timing? The universe has existed for over 13 billion years, and intelligent life may have existed long before humanity arose on Earth. If civilizations rise and fall, as we suspect, there may have been other species that reached the same level of advancement we have today, but they disappeared before we had the technology to detect their existence. It's possible that extraterrestrial civilizations exist or have existed in distant galaxies, but they may be so far removed from us in time and space that their signals, their technology, or even their physical remains have already dissipated. The universe may have already hosted countless civilizations, but their rise and fall happened long before we could detect them, making us feel like we're alone, when in fact the history of intelligent life in the universe could be much richer and more complex than we realize. Another possibility is that life is indeed common, but alien civilizations are deliberately hiding from us. This idea, which has been discussed in the context of the zoo hypothesis, suggests that extraterrestrial civilizations may be aware of us, but they are intentionally refraining from making contact. There could be ethical or strategic reasons for this. Perhaps they are waiting for humanity to reach a certain level of technological or moral maturity before they reveal themselves. Or perhaps they are following some form of cosmic non-interventionism, similar to the Prime Directive in Star Trek, where more advanced civilizations avoid interfering with less advanced ones. In this scenario, the silence we experience may not be a sign of the absence of life, but of a decision not to make contact until we are ready. If life is common, but we've just missed it, it has profound implications for how we view our place in the cosmos. The realization that we might be overlooking abundant life could change our entire approach to the universe. It would encourage a more open-minded exploration, one that doesn't simply look for life that mirrors our own, but embraces the possibility that life could take forms we can't yet imagine. It would also suggest that we are not unique in our quest for meaning, understanding and connection. There may be countless other civilizations out there, each on its own journey to discover its place in the cosmos, and the silence we experience may simply be the result of our limited perspective, not the absence of life. The question of whether we have missed life, and whether it is truly common in the universe, is one of the most profound questions we can ask. It challenges our assumptions about our uniqueness, and forces us to reconsider the nature of life itself. Whether we are truly alone or part of a vast cosmic community, the search for life is a reminder that we're a small piece of a much larger, more complex puzzle, a puzzle that may hold answers to some of the deepest questions of existence. The idea of being alone in a boundless universe is a deeply unsettling concept for many. We are taught, from the moment we can comprehend the vastness of the cosmos, that the universe is enormous, teeming with countless stars, planets, and possibilities. As our understanding of the universe deepens, it becomes clear that Earth is a small speck in the grand scheme of things. Yet, despite the scale of the universe, we find ourselves asking one of the most profound questions in human existence. Are we alone? The silence of the cosmos is deafening, and for many this question becomes more than just an intellectual pursuit. It becomes an emotional and existential one. What does it mean for our psychology, our sense of self, and our place in the universe if we are truly alone? How does the possibility of isolation in a boundless, infinite cosmos shape our view of existence? To explore this question, we must first recognize that the idea of being alone in the universe taps into one of the most fundamental human fears: loneliness. The fear of being alone is not just about physical solitude, it's about existential isolation, the feeling that we are disconnected from the world around us, or worse, from any other conscious beings in the cosmos. For most of human history, we have looked to the stars for guidance, for meaning, and for connection. The idea that we might be the only conscious beings in an otherwise silent and indifferent universe strikes at the heart of our existential anxieties. From a psychological perspective, the concept of existential loneliness is deeply tied to our awareness of our own mortality and the limitations of our existence. As human beings, we're keenly aware of the brevity of our lives, and this awareness creates a sense of isolation. We are born, we live, and we die, all within a small window of time in the history of the universe. The universe, on the other hand, is vast and eternal, indifferent to our fleeting existence. The possibility that we are the only intelligent beings in the cosmos only intensifies this sense of isolation. If we're alone in the universe, it suggests that our existence, our thoughts, our feelings, and our dreams may be unique, an anomaly in the vast expanse of space. This existential isolation can provoke a range of psychological responses, from a sense of futility and despair to a profound yearning for connection. The fear of being alone in the universe can also be linked to the search for meaning. As human beings, we are meaning makers. We seek to understand our place in the world, to find purpose in our actions, and to connect with something larger than ourselves. The idea that we might be the only intelligent life in the universe forces us to confront the unsettling reality that there may be no greater purpose or cosmic community to belong to. The search for extraterrestrial life in many ways is a search for meaning. We hope that by discovering other intelligent beings, we can share in the universal quest for understanding and purpose. But if we are alone, if there is no other civilization to engage with, then we are left to find meaning within ourselves and our own existence. This is a heavy psychological burden, one that can evoke feelings of emptiness and existential angst. Interestingly, the loneliness of being alone in the universe also forces us to turn inward. If we cannot find meaning or connection in the cosmos, we must create it ourselves. The notion that we are alone in a boundless universe challenges us to redefine what it means to be human and to find purpose in our own existence. This can lead to profound self-reflection and growth. As humans, we are capable of creating meaning through relationships, through our contributions to society, and through the way we engage with the world around us. Being alone in the universe in this sense could inspire a more profound understanding of our own individuality and capacity for meaning-making. Instead of looking outward to the stars for validation, we are challenged to look inward and create our own sense of purpose and connection. However, the psychological toll of existential loneliness is not easily dismissed. The concept of the absurd, as articulated by philosophers like Albert Camus, explores the tension between our desire for meaning and the apparent meaninglessness of the universe. For Camus, the realization that the universe is indifferent to human existence and that we may be alone in the cosmos forces us to confront what he called the absurd. The absurd is the dissonance between our longing for connection and understanding and the reality of a silent, indifferent universe. This tension can lead to feelings of despair, but Camus also argued that it can lead to a kind of freedom. The freedom to create our own meaning in a universe that offers none. In this sense, existential loneliness is both a curse and an opportunity. The absence of external meaning forces us to confront our own existence and find our own path, regardless of the universe's indifference. Another psychological response to the possibility of being alone in the universe is existential dread. The awareness that we're alone in a vast and uncaring cosmos can provoke intense feelings of fear and uncertainty. In the absence of external life or cosmic purpose, we may question the point of our efforts, our relationships, and our achievements. What does it matter if we achieve great things if no one else is around to witness them, or if we're just a fleeting blip in the history of the universe? This can lead to existential nihilism, the belief that life has no inherent purpose or meaning. The fear of existential loneliness can push us toward a crisis of meaning, where everything we once held to be significant seems insignificant in the face of cosmic isolation. However, existential loneliness can also have a transformative effect on individuals and societies. The awareness of our isolation in the universe can foster a deeper sense of connection with those around us. It can highlight the importance of human relationships and the need for empathy, understanding, and cooperation. In the face of a cold and indifferent universe, the bonds we form with one another become more precious, more meaningful. The realization that we may be the only intelligent beings in the cosmos can push us to value our time on Earth, to protect our planet, and to make the most of our relationships. In this way, the loneliness of the cosmos becomes a call to action, to live fully and meaningfully despite the apparent meaninglessness of the universe. In the broader cultural context, the idea of being alone in the universe can also inspire creativity and exploration. Throughout history, humanity's quest to understand the cosmos has led to incredible achievements in science, art, and philosophy. The search for extraterrestrial life, for instance, has driven scientific innovations and fueled cultural imagination. Whether through the development of telescopes, space probes, or the creation of science fiction, the question of extraterrestrial life has pushed humanity to explore the unknown, to imagine new possibilities, and to reach for the stars. In this sense, the loneliness of the universe can be a powerful motivator, urging us to seek meaning in the cosmos, even when the universe seems silent. The psychology of being alone in a boundless universe, therefore, is complex and multifaceted. While the idea of cosmic isolation can provoke feelings of despair, loneliness, and fear, it also offers the opportunity for profound self-reflection, creativity, and meaning-making. Being alone in the universe forces us to confront the reality of our existence, to create our own purpose, and to find meaning in our relationships and in the way we interact with the world around us. The loneliness of the cosmos is not an absolute truth. It is a challenge that, when faced with courage and introspection, can lead to a deeper understanding of our place in the universe. Ultimately, the question of whether we are alone is not just about the absence of others, but about how we choose to engage with the vast emptiness of space and the finite nature of our existence. The Fermi paradox, which has long intrigued scientists, philosophers, and space enthusiasts alike, raises a profoundly simple but deeply unsettling question. If the universe is so vast and full of stars, each potentially hosting planets capable of supporting life, why haven't we detected any signs of extraterrestrial civilizations? The question seems obvious, almost naive, yet it has left humanity searching for an answer for decades. Despite our best efforts, with radio telescopes reaching out to the stars, space probes sent to distant planets and moons, and increasingly sophisticated detection methods, we still have no conclusive evidence that we are not alone. The universe appears to be vast and teeming with potential for life, yet it remains eerily silent. For decades, the answer to the Fermi paradox has been elusive. The sheer number of stars in the galaxy, coupled with the ever-growing discovery of exoplanets, many of which sit in the Goldilocks zone, the habitable zone where life could theoretically flourish, suggests that life should be common. In fact, according to the Drake equation, which attempts to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way, there should be tens of thousands of civilizations capable of communicating with us. And yet, despite the vastness of the cosmos, there is silence. No signals, no encounters, no evidence that other intelligent beings are out there. This paradox has led to the development of many theories, each attempting to explain why we hear nothing despite the odds being in favour of extraterrestrial life. Some theories lean towards the idea that intelligent life is extremely rare. Others argue that advanced civilizations might be deliberately avoiding us, while some suggest that we're simply not looking in the right way. But one thing is clear: the Fermi paradox is not just a scientific question. It forces us to reconsider everything we know about life, intelligence, and our place in the universe. One of the most widely discussed explanations for the Fermi paradox is the Great Filter hypothesis. The Great Filter proposes that there is a crucial barrier, perhaps a sequence of stages or a single catastrophic event, that prevents most civilizations from reaching the technological threshold needed to communicate or explore the stars. This filter could occur at any point in a civilization's development, from the emergence of life itself to the jump from simple organisms to complex life, to the rise of intelligence, or even to the point where a civilization becomes technologically advanced enough to destroy itself. The Great Filter hypothesis suggests that most civilizations never make it past this critical point, and thus we are unable to detect them. In this scenario, the silence of the universe is not a coincidence, but a reflection of the fact that most civilizations fail before they can establish interstellar communication. This theory brings with it a chilling question. Have we already passed the Great Filter, or is it ahead of us? If the filter is behind us, then humanity is one of the rare species that has managed to make it past the point where many civilizations have failed. This would mean that, despite the odds, life on Earth has already overcome the most challenging stages of evolution, and our survival is an extraordinary, unlikely achievement. However, if the Great Filter is ahead of us, then humanity could be on the brink of facing a challenge so great that it could prevent us from becoming an interstellar species, or even continue our existence in the long run. The silence could then be a warning, suggesting that civilizations inevitably fail, and that the barriers we have yet to face, technological dangers, environmental collapse, or the inability to manage our own power, are the real threats to our survival. Another theory posits that intelligent civilizations are out there, but they may be deliberately avoiding contact with us. This theory, known as the zoo hypothesis, suggests that extraterrestrial civilizations are aware of us, but are choosing not to make contact. Perhaps they have a moral or ethical guideline that prevents them from interfering with less developed civilizations, much like the Prime Directive in the Star Trek universe, which forbids advanced civilizations from intervening in the natural development of less advanced species. If extraterrestrial civilizations are deliberately avoiding us, it raises important questions about what such an advanced society's reasons for non-interference would be. Maybe they believe we aren't ready for the knowledge or technology they could offer, or perhaps they view us as too immature or unstable to handle contact responsibly. This hypothesis also brings a sense of comfort in the face of the Fermi paradox. Instead of thinking that we are alone because there is no one out there, we might find solace in the idea that we are being observed, monitored, or perhaps even protected by more advanced beings. They might be waiting for us to evolve to a level where communication would be safe and beneficial for both parties. In this case, the silence would not be an indication of absence, but of an intentional cosmic restraint, a policy of non-interference. Alternatively, the Fermi paradox could be explained by the idea that life is simply too rare to detect, and we are alone in the universe after all. The rare Earth hypothesis argues that the conditions necessary for intelligent life to arise are so specific and improbable that Earth might be a unique, almost freakish occurrence in the galaxy. While microbial life could be widespread, the jump to complex intelligent life might require such a unique combination of factors that we are the only civilization in our corner of the cosmos. The rare earth hypothesis suggests that we are in fact alone in the universe, a notion that is as lonely as it is humbling. The silence of the universe, then, may be a reflection of the fact that intelligent life is a rare and fragile phenomenon, a brief flicker in the long history of the universe that is difficult to sustain. The emergence of life, especially complex intelligent life, might require such specific conditions that it occurs only once in a vast expanse. Our solitude in the universe could be a stark reminder of how unlikely our existence truly is, and could redefine humanity's place in the grand scheme of things. But perhaps the universe is filled with life, and we just haven't found the right method to detect it yet. This theory suggests that we may be searching in the wrong way or using the wrong technology to look for extraterrestrial intelligence. For centuries, our understanding of life was based solely on the limitations of Earth biology and chemistry, and it's possible that life elsewhere is not based on the same principles that govern life here. We look for water, for carbon-based life, and for familiar forms of communication. But extraterrestrial life might not require the same building blocks, or might communicate in ways we cannot yet detect. Life might exist in environments far beyond our conception, like the ice-cold moons of Jupiter or the toxic clouds of Venus, and could be beyond the reach of our current methods of detection. If this is the case, the silence of the universe is not evidence of a lack of life. It simply reflects our current limitations in recognizing it. The Fermi paradox is a puzzle that touches on some of the most fundamental questions of existence. Why are we here? How did life arise? Are we alone? As we continue our search for answers, the paradox challenges us to reconsider our place in the universe. The silence we encounter might not be a dead end. It might be the beginning of a much deeper, more complex exploration. Whether we are looking in the wrong places, or whether the universe itself is too full of risks and filters to allow for the long-term survival of intelligent life, the journey to understand our cosmic isolation is far from over. The more we search, the more we learn, not just about the universe, but about ourselves and our place in the vast, quiet cosmos. The future of humanity is a question filled with both hope and uncertainty. As we advance technologically, scientifically, and socially, we are simultaneously confronted with the immense unknowns of our existence. One of the most profound and unsettling questions about humanity's future is whether we are doomed to be alone in the universe. For millennia, we have looked to the stars, imagining that we might one day make contact with other civilizations, that we might find companions in the vastness of space. But as our searches continue, we are met with silence. The universe, so seemingly full of potential, appears to be empty of any intelligent beings. Could this silence mean that we are truly alone, or is it a sign of something deeper, something that we have yet to understand? The question of whether humanity is destined to be alone in the universe is intricately tied to the search for extraterrestrial life, which has been one of the defining endeavours of modern science. From the early musings of ancient philosophers to the groundbreaking efforts of the search for extraterrestrial intelligence, SETI, humanity has long been obsessed with the idea of finding other intelligent beings. The vastness of the cosmos suggests that, with billions of stars and potentially even more planets, the odds of finding life beyond Earth should be high. Yet, despite decades of searching, we have found no definitive evidence of extraterrestrial intelligence. The silence is deafening. This silence raises an uncomfortable possibility. Are we alone? If the universe is teeming with planets capable of supporting life, why have we not yet encountered any signs of life? The question goes beyond just curiosity. It touches on our sense of significance and purpose. If humanity is truly the only intelligent species in a vast and uncaring universe, what does that mean for our place in the cosmos? Are we a fluke of evolution, a rare anomaly in the great expanse of space? Or is there something more to this silence, something that we have yet to understand. One theory that attempts to explain the silence of the universe is the Great Filter. This concept suggests that while life may be common throughout the cosmos, intelligent civilizations capable of space exploration or communication are exceedingly rare. The Great Filter posits that there are critical stages in the development of a civilization, biological, technological, or social, that are incredibly difficult to pass. For most civilizations, these barriers prove insurmountable, causing them to self-destruct or stagnate before they can reach the stars or make contact with other civilizations. If the Great Filter exists, it could mean that humanity is either one of the rare exceptions that has passed through the filter, or that the most challenging barrier lies ahead of us. In either case, the possibility that we are doomed to be alone could be a sign of the fragility of advanced life. We might be living in a unique moment in cosmic history, or we could be facing the same existential challenges that have caused countless civilizations to fail before us. Yet, even if we are alone, this doesn't necessarily mean that humanity is doomed. In fact, the realization that we might be the only intelligent beings in the universe could drive us to create our own meaning and purpose. If we are indeed alone, then the responsibility for the future of life in the cosmos falls squarely on our shoulders. We would be the sole inheritors of the universe's potential for intelligence, culture, and progress. The future of life itself would be shaped by our actions, our decisions, and our ability to navigate the challenges that lie ahead. In many ways, the question of whether we are doomed to be alone is not just about extraterrestrial life. It is about humanity's ability to find meaning and purpose in the face of isolation. If we are the only intelligent beings in the universe, we would have the unique opportunity to create something extraordinary, to build a future that reflects our values, our aspirations, and our shared humanity. The silence of the universe could be a call to action, urging us to make the most of our time on Earth, to foster cooperation, and to work together to address the existential challenges that threaten our survival. Rather than succumbing to despair, we could use our aloneness as an opportunity to create a more meaningful and connected existence. Yet the possibility of being alone in the universe also brings with it profound psychological implications. For millennia, humanity has sought connection and meaning in the cosmos, whether through religion, philosophy, or the search for extraterrestrial life. The idea that we are the only intelligent beings in the universe forces us to confront our own significance in a vast and indifferent cosmos. The fear of loneliness in the universe touches on the deeper human experience of existential isolation, the recognition that despite our connections to each other, we are ultimately alone in our experience of life. The vast emptiness of space mirrors the inner void that many feel, and the silence of the cosmos amplifies the existential questions that each of us must grapple with. The psychology of loneliness in the universe is not just about the absence of alien life. It is about how we come to terms with our own aloneness in a universe that offers no clear answers. If we are alone in the universe, it may force us to reflect on the nature of our existence and the meaning we derive from it. Existential philosophers like Jean-Paul Sartre and Albert Camus explored the idea that the search for meaning in an indifferent world is both a source of suffering and an opportunity for personal freedom. The awareness of our solitude in the cosmos could push us to define our own purpose and create meaning through our relationships, our work, and our contributions to the world. In this sense, the potential loneliness of the universe could become a source of strength, rather than despair. If we are alone, it means that humanity has the freedom to shape its own future, to make choices without the influence or interference of other civilizations. We have the power to decide what kind of society we want to build, what values we want to uphold, and how we want to interact with the world around us. The silence of the universe may be a reflection of our own ability to create meaning, to find purpose within ourselves, and to shape our destiny as a species. The future of humanity, then, may not depend on whether we find extraterrestrial life, but on our ability to navigate the challenges we face on Earth. Whether or not we are the only intelligent species in the universe, we have the responsibility to protect our planet, preserve our environment, and ensure that future generations can thrive. The question of whether we are alone in the cosmos may be secondary to the question of whether we can create a future that reflects our highest ideals, values, and aspirations. If we are the only intelligent beings in the universe, then it is up to us to make that existence meaningful. In the end, whether or not we are doomed to be alone in the universe depends not on the cosmos, but on us. If we choose to embrace the silence of space as an opportunity for self-discovery, creativity, and growth, then we can shape a future that is both meaningful and hopeful. The question of whether we are alone is not just about life beyond Earth. It is about how we live here, on this small blue planet, and how we define our place in the universe. The idea of being alone in the universe, isolated in a cosmos that appears vast, indifferent, and silent, can be daunting. It confronts us with the unsettling realization that, despite the overwhelming vastness of space, we might be the only intelligent beings capable of thought, reflection, and questioning in an otherwise empty universe. Such a thought might evoke feelings of despair, insignificance, and profound loneliness. Yet, rather than viewing this loneliness as a curse, there is an undeniable potential for it to serve as a source of hope and responsibility, a call to action that encourages humanity to not only consider its place in the universe, but to rise above the challenges that come with this realization. Being alone in the universe, if it turns out to be true, presents humanity with an immense responsibility. The responsibility to safeguard life, to preserve civilization, and to ensure that the rare spark of intelligence we possess is not extinguished. If we are indeed the only conscious beings in the cosmos, then it is up to us to protect our future, to learn from the mistakes of our past, and to create a future worthy of the incredible potential we have as a species. This responsibility doesn't just involve the survival of humanity, but the stewardship of life itself, both on Earth and potentially beyond. As the sole bearers of intelligence and consciousness, it is our duty to ensure that we do not squander this opportunity, but use it to build a future that is reflective of our highest values. The responsibility of being alone also brings with it the freedom to define our future. With no external entities to guide us or intervene in our development, humanity stands at the precipice of shaping its own destiny. We can chart our own course, guided by the principles of compassion, sustainability, and unity. The knowledge that we may be the only ones who can think, reason, and create offers us the unique opportunity to reflect on how we want to live, what legacy we want to leave, and how we want to interact with the universe around us. This realization provides a profound sense of empowerment, the ability to shape our own fate without the need for approval or intervention from any other life form. Moreover, being alone in the universe could be a driving force for unity. Knowing that there is no one else to rely on, no other civilization to turn to for help or understanding, may inspire us to work together in a way we have never done before. Our isolation could be the catalyst for creating a more connected, empathetic world, a world where humanity comes together, setting aside its differences to focus on shared goals, the preservation of life, the protection of our planet, and the pursuit of the knowledge. In the absence of external pressures, we have the opportunity to create a society that transcends borders, divisions, and conflicts, one that recognizes our shared responsibility as the caretakers of Earth and perhaps of the universe itself. The solitude of the cosmos also forces us to consider the fragility of life. If we are alone, then the life we possess, the consciousness we carry, is uniquely precious. Life on Earth, from the simplest microbe to the most complex human civilization, is part of a fragile web, one that could easily unravel if we fail to care for it. In this context, the idea of being alone in the universe serves as a stark reminder of how fleeting life is and how vulnerable we are. This awareness can become a source of profound gratitude, encouraging us to cherish the life we have, the relationships we form, and the world we live in. Rather than viewing the potential loneliness of the cosmos as a burden, we can see it as a call to appreciate the beauty of our existence and the immense responsibility we have to preserve it. In the absence of other civilizations, the hope for humanity lies in the potential we have to create meaningful lives and leave a positive impact on the universe. The absence of external voices means that our voice, the collective voice of humanity, has the potential to become louder, clearer, and more impactful. We are the ones who can shape the narrative of life in the universe, whether it is through scientific discovery, artistic expression, or moral development. Humanity has the potential to create meaning that resonates far beyond the limits of our planet. The idea that we are alone forces us to confront the importance of our actions, our values, and the way we interact with the world. It is a call to live with purpose, to recognize the uniqueness of our existence, and to make decisions that reflect the responsibility we have as the sole intelligent life forms in an indifferent universe. But perhaps the most powerful aspect of being alone in the universe is the potential it gives us to embrace the mystery of existence. If there are no other civilizations to contact, no other life forms to share our journey with, then the meaning we derive from our lives must come from within. The challenge becomes not finding others, but finding ourselves, discovering what it means to be human, to experience consciousness, and to seek knowledge. The vastness of space may seem cold and unyielding, but it also provides us with the canvas on which to paint our story. We are not bound by the expectations of other civilizations. Instead, we are free to explore, to learn, and to create meaning in a universe that offers no inherent answers. The future of humanity, then, is not defined by the question of whether we are alone in the universe, but by how we respond to the reality of our existence. If we are indeed the only intelligent life, we have the unique responsibility to take care of our planet, to protect the life we have, and to shape a future that reflects the potential of our species. The responsibility of being alone is not just a burden, it is an opportunity. A chance to build a world that embraces the fragility of life, the beauty of our individuality, and the strength of our collective potential. Whether or not we're alone in the universe, we have the power to create a future that is worthy of the incredible gift of life that we hold in our hands. The silence of the cosmos is not a void, but a challenge to make our mark, to live with purpose, and to ensure that the flame of consciousness burns brightly in the infinite expanse of space.